All aboard! We are now starting our journey towards the final event for Flagship Project 1, Motional. Please sit down and fasten your seatbelts.
Good morning, everybody. My name is Roberto Majorana, and I'm the Director General of the Swedish Transport Administration, also known as Trafikverket. And you are all warmly welcome to the Flagship 1 Motional's final event, broadcasted from our office studio in Stockholm. And during the day, we will also have the privilege of being visited by partners from other studios in Europe. We are very pleased to host the Flagship 1 Motional's final event. We're also proud and happy to be part of the Europe's Rail joint undertaking where we together contribute to improve and strengthen the railway network and its ability to meet society's transport needs and tomorrow's transport challenges. Europe's rail has a high strategic value for Trafikverket. Participation is motivated and it is very attractive to be involved. And I notice a pleasing shift in the industry as a whole, and the cooperation within Europe's rail is a contributing factor. We are moving from a period with many deadlocks to a situation where we focus together on finding solutions. Technical systems, standards and traffic are interconnected across national borders. Europe's rail gives Trafikverket the opportunity to influence developments, gain early insight into upcoming changes and integrate into European solutions. Overall, it is expected to lead to reduced fragmentation, a well-functioning supplier market, increased interoperability, lower costs, and happy customers. Sweden and Europe's cohesion, security and competitive strength are based on a functioning transport system. Travel and transport are borderless in today's global society. Climate and environmental challenges as well as safety and security issues do not respect national borders. It is obvious that we need to work together. Collaboration with internationally recognized partners support and accelerate the use of digitalization. It contributes to the development of needs-based technology and even to disruptive innovation. As members of Europe's rail joint undertaking, we are all committed to contributing to the harmonization and building of a sustainable and efficient railway network that creates benefit and value for European society, its citizens and business. That is something to be proud of. Trafikverket participates in all flagship areas within Europe's rail, and it is essential for us to continue that work, and the capacity planning, traffic management has historically been strongly anchored in Trafikverket. And we also have prominent research in the area at our universities and higher education institutions. And I also note that a large part of the commitment from our citizens, customers and politicians and the media often concern capacity and punctuality issues. Therefore, it is important for us to have a strong position in the flagship, both to contribute to and benefit from the joint work in strengthening the railway system. And thanks to our joint efforts, both within Shift to Rail and Europe's Rail, we have developed several innovations with a high level of technical maturity. We have also collected and analyzed enormous amounts of data and conducted countless simulations to deliver even more effective decision support for capacity planning and train management. At the same time, we have increased our understanding and ability to translate digitalization into actual collaboration. And I'm thinking, for example, of the connected driver advisory system, which is an important piece of the puzzle for better communication and decision support between traffic management, train drivers, and train staff. And we also have collaborative decision-making, which creates a situational picture that makes possible to act together when the unpredictable occurs. And as an experienced railway worker once told me, it cannot be avoided that the machinery occasionally gets stuck. But what separates the professionals from amateurs is how quickly they get back on track. So this resonates well with our saying at Trafikverket, Sweden must never stop. This also applies at the European level. And it is my belief that initiatives such as Europe's Rail are a guarantee that Europe's railway network never stops. So today, we celebrate that the first and largest delivery, Wave 1, within the flagship One Motional, is coming to an end. However, it is not yet finished. The important work will continue during waves 2 and 3. In parallel, we will continue to bridge the gap between research and successful market launch, as well as apply and implement the solutions and innovations that have been developed, so it provides real benefit. Persistence is needed here. To hold on and persist are crucial for the successful delivery of an integrated European rail system with high capacity. And this will make Europe stronger and safer. And it also contributes to a successful and attractive industry so that we can retain, develop and recruit the skills we need. So for Trafikverket, as an authority responsible for long-term planning of the transport system on land, at sea, and in the air, as well as for construction, operation and maintenance of the state roads and railways, we are extremely aware that the transport network is interconnected. We also know that railway system itself is both complex and complicated. So therefore, the collaboration within Europe's rail, where industry, academia and society together contribute solutions to a digital, sustainable and reliable railway system, is an unparalleled concept that needs to be broadened, deepened and grow stronger. We at Trafikverket did not join Europe's rail because we thought it would be easy. We joined because we saw the necessity for Sweden to be connected to the rest of Europe in a cross-border, seamless railway network. And we joined because cooperation is the only way to deliver what our customers, passengers and society at large demand: accessibility, capacity and punctuality. We joined to contribute to competitive, interconnected and secure Europe. We joined to realize the vision of rail as the backbone of the European transport system. So finally, I would like to thank everyone who has contributed and will continue to contribute to the work within Flagship 1 Motional. You create social benefit. I would also like to thank the entire railway industry for seeing, understanding, and listening to the needs of us as infrastructure managers in Trafikverket. And last but not least, I would like to thank our passengers and logistic customers who choose the rail as their preferred mode of transport. Keep it up. Do the locomotion.
Everybody's doing a brand new dance now. Come on, baby, do the locomotion. I know you get to like it if you give it a chance now. Come on, baby, do the locomotion. My little baby says I can do it with me. It's easier than
So, welcome and thank you, Roberto, for this wonderful introduction to this exciting day that we have in front of us. My name is Linda Thulin, and I have the pleasure to guide us through this day today and today's journey of the future innovations. It is really my day-to-day business to make rail work better across borders and across Europe. In my roles as the Vice President of RailNet Europe, the President of RFC ScanMed, and also Head of International Relations at Trafikverket. So it started a long time ago with steam locos, and then we evolved at rail to the electrification of rail. And now we are in the next huge transformation of rail, the digitalization and automation. And this is really what Europe's Rail Flagship 1 is about. To present us some and test and explore, and here today it will be 4 years results of research of digitalizations and solutions that we then can cherry pick from to select and hopefully then also roll out in full scale across Europe. So all of this because that passengers and freight can run and trains and be transporting themselves and also the goods smoothly across border. Because what we sometimes say at RailNet Europe, when rail works better cross-border, Europe works better cross-border. So now it's actually time for the next keynote speaker. So therefore in the studio I have here with me Giorgio Travaini. A warm welcome, the Executive Director of Europe's Rail. And now you will describe for us and the listeners today why it is so important with this Flagship 1 and the results of Europe's Rail.
Thank you very much, Linda. Happy to be here. Today is a day of a celebration. It's the end of the Flagship Project 1, but it's also a day of dissemination and making sure that our results are well known. And Roberto mentioned it already. What is important is to collaborate together across Europe. And why? Because our vision in Europe's rail is really to create a fully integrated European rail network for the benefit of our citizen, passenger, and cargo user. And for this to happen, we really see digitalization as a key enabler of how we manage our network, our fleets, our train, and our assets. And digitalization in the context of the rail industry clearly provide a lot of benefit if it is used, if it is applied in a correct way, coordinated way, because rail is a system and Europe is the network. What I would like to explain to you briefly today is that Europe's rail is not working on solving problems. Europe's rail is there to find European solution. And this is what in the flagship areas we would like to achieve. We would like to build up a solution for a dynamic network traffic management that works at European scale and that provides harmonized function for agile, borderless, and mixed traffic operations. So all our work you will see today, when I say our, is thousands of engineers across Europe that are working together to achieve results. So we're not doing just research for research. First, we're producing demonstrations that are, let's say, providing evidence that the technical solution are available and work, and you can see there some example about this. And it's also about interconnecting existing system, because the railway system has been built from a national perspective all over these years. And we needed to bring them together, and we need also to ensure that everybody knows what are the steps necessary to arrive to a fully connected, digital, automated, and cost-effective also rail system. As Roberto also mentioned, the end of FP1, the flagship project 1, is not of the end of the journey. What we can see is that there are different phases needed after that, and this is embedded in the program of Europe's Rail. Those phases, we called it WAVE. Soon we will start the Wave 2 projects, and then we will end it up with the Wave 3 for really coming out with operational concept and output. Some output that I would like also to highlight is also the link that we have of our work with European rules and regulation. For example, there is a new capacity regulation that is coming in, creating the possibility of managing capacity at network level, which is Europe, together, but you needed to have some technical enabler to do this. And the work that we have achieved in Europe's Rail will provide a ground to make actually possible what the legislator would like to implement, but especially what the rail system needs. And what is coming next? It was also mentioned before that innovation to market is what we need. We are achieving with the results of Europe's Rail TRL 6, 7, 8 maximum. So we're reaching a very close to the market level of innovation, but it's not yet innovation because it's not yet fully implemented into the market. So we need, first of all, to ensure alignment between actors, but also we need to address the so-called valley of death, which is alignment with standardization, alignment with industrial capabilities, and so on. And this is a bit a glimpse on the future that I would like also to provide to you, because we are reflecting in the context of Europe's Rail what the next program of Europe's Rail in the next multi-annual financial framework of the European Union could be. And here it's a very simple glimpse. You can find more information on our website, but we would like really to simplify the rail system. And the work that FP1 has been doing, it's a cornerstone for this, because we're putting together very diverse national network to have them working in tandem and working with new technology. So new technology don't add up complexity, but actually aim at harmonizing and reducing complexity and making rail more agile, more resilient, and more competitive. And the areas that we have for the moment identified for the future, it's a simplified integrated rail system, which is highly automated, digitalized. Again, the output of FP1 are essential. The next generation of rail freight operation in Europe, also this one, it's rail freight operation is international by default. So the output of a connected traffic management system and highly automation, it's absolutely needed. Resilient and recoverable rail system. If a disruption happens in the network, we need to be able to quickly reroute and making sure that the passenger and cargo don't have to wait to arrive to their destination. So real-time management is also one of the areas we've been working on. And the last bit, it's about high speed. So high speed is in general a flagship of rail, but today in Europe, it's a segment or isolated island. We want to connect those islands and to create a network again. And you can see here that all the work that FP1 has done are all essential elements to build up our future. I think I finish here, Linda.
Thank you, Giorgio. So interesting, and thank you for sharing this. And I would say that this, what you illustrate here, really shows why Europe have chosen to invest so heavily in innovations, to really set the building blocks of the future rail. And I remember it's a couple of years ago now when we met the last time in an event like this, but live, even though this is live broadcasted from Stockholm, where we actually signed a contract together between RailNet Europe and Europe's Rail. And the intention then was that we would close and ensure that the innovations that Europe's Rail are developing actually also are being taken care of in reality and then also full-scale rolled out. Have this worked in practice? How is the cooperation today between Europe's Rail and RailNet Europe?
I think it has, and especially in the context of FP1, it's important that all innovation that we do respond to the client needs.
Yeah.
And in R&E, we have obviously the infrastructure managers that are present. We have them also in Europe's Rail, but also together with the industry. So it's important to drive it through in this direction. And I think that all the output of FP1 are absolutely essential for the next step of creating capacity management at European level.
Yes, indeed. And now we have the capacity regulation published. So now we also have legal requirements to evolve a railway and do this transformation to the new way of working, which Europe's Rail solutions will be very helpful, I'm sure of it. So thank you so much again, Giorgio, and we will now go on to move on to the third keynote speaker for today, Lars. Yes, so to help us understand better how all of these innovations fit together, I am delighted to have Lars Dieting here with me in the studio, who is the coordinator of Flagship 1. So a warm welcome, and the stage is yours.
Many thanks, Linda. Yeah, and also from my side as coordinator, dear distinguished guests, partners and experts, a warm welcome to our final event. I guess that most of you have attended our specific events where we went into the last detail of the innovations, so I'm not going too far into the technical detail now. What I want to point out in the next 8 minutes is just how we cooperated. That was tackled already before, that cooperation is very important. But also to give you a little bit a storyline, which you should keep in mind over the day when you listen to the respective innovations, so that you can get a feeling about what has been done. And as you know, Motional was the first step. There will be 2 more waves to be done. And yeah, just imagine, you have seen there, we have different working groups, so subgroups. If you are either container or passenger, and you want to do a trip across Europe, then it starts far earlier that you can do it than what you recognize during your trip itself. So we start with the planning of the network. We start with the timetable planning, which needs to be properly done. Then these timetables have to be adjusted continuously because there are always disruptions in the network. So all these kind of things, to have really an optimized usage of the capacity, is more or less part of our subgroup 1. But then, for sure, when it comes to operation, it's so important to have a more or less in real time optimization of the usage of the capacity. And this, considering that we have mixed lines, it was tackled before, we don't have separate lines in most parts of Europe. And that means we have to find a good balance between freight and passenger needs. And there, a lot of topics occur out of, let's say, out of a sudden. So we have to be really flexible and nevertheless efficient. Flexibility is often also a problem. So that is then subgroup 2. And you heard it before, we are talking about Europe. We are not talking about one country. So we are talking a lot about cross-border. And cross-border, having our national systems, our brownfield solutions, where we have a lot of very complex and huge systems in place, which need to be adapted, which need to be interoperable and connected. That is really a large target and a very complex work. And the colleagues, and here we have more than 90 partner companies, they did a great job in the last years. And we can only give you a very small glance in the next hours. So we selected some highlights, but also some other highlights cannot be presented today, but you can find them on our project website. So at the end, when we are talking about the customer, so the real user in subgroup 3, we tackled more really the user needs from the passenger experience, because, you know, with flagship project 5, we have a dedicated freight flagship project. So there the freight topics are more handled. And yeah, subgroup 4, everything about digitalization, digital twins. You will learn a lot today. And if there are more questions, for sure, you're welcome to visit the website and to contact the partners. So imagine you are really the passenger using a European trip or a container. And then over the day, you will learn what piece by piece we have worked on to develop the system in a better way, to have it more interoperable, more flexible and more intelligent. So I think these are the key topics, but maybe Linda, you have some additional questions to me, which I should point out.
Yeah, thank you, Lars. And I must say, I'm really looking forward to be the passenger in your future rail system. It will become easier and more easy for me to access. It will be smoother, hopefully faster. And what is happening there behind the scene, I don't need to worry so much about.
Yeah, and this is really the interesting question, because there is a lot what needs to be done in the background. So to prepare this seamless passenger journey. So all the data exchange, it sounds always so easy, but not only the technical topics, but also who can share which kind of data between which companies, and all the regulations behind is so complex. And it's really an interesting journey to see step by step how we get to this European railway area and to a European ticket. And that's what the colleagues prepared, and they will announce this afternoon.
Yes, and there are so many great solutions that you have produced during those 4 years. And sometimes they are also a little bit in the same area. How would we be able to do the cherry picking in between all of those options for solutions that we have?
I think we don't have the chance to do real cherry picking, because what we have to ensure is that all the various brackets really fit together, because it's so complex. Not a company alone can change anything. So it must really be a joint endeavor, a joint work to bring things forward. And that is also what was really the mood between these nearly 100 partner companies. In several cases also competitors, sitting at the same table, but we all had the same need, the same wish for improvement. And that is what I really liked. So in the consortium, it was a It was a family, it was a team. And only like this you can have really the power to bring things forward. If you're always looking aside, then you will not win anything.
Yeah, indeed. And it's been very clear that you have a joint target, joint goals, and you have really smartly as a coordinator, I must say, because I have also been participating in some of the sessions. It's connecting people, connecting systems, connecting rules and systems, and connecting countries, and then something magic happens.
Yeah, definitely. And when you say cross-border, it sounds so easy.
Yeah.
But cross-border is so much.
Yeah, it's complicated.
And it's also borderlines in mentalities.
Yeah.
In different, let's say, ways of having, let's say, company perspectives also between infrastructure managers. So they have different ideas about how things could be improved, and to bring this together so that we have on a European transport corridor really one joint, let's say, offer in a proper way. It's very interesting. So I really like to see how we progressed, but there is a lot which needs to be done in future.
Yeah.
So I'm looking forward to wave 2 and wave 3. And I think we will make a huge step forward, but working on a really efficient railway system will never end.
Yeah, indeed. There is always something to do. We don't need to worry about getting unemployed.
Yeah,
that's for sure.
definitely.
There's always something.
In some years, I want to be the passenger only.
Yeah. Okay. Yes. So now we had 3 wonderful keynote speakers here with us, kicking off this wonderful day. And I'm so excited now to dive into the different technical solutions. So we will start now with the technical session on cross-border operations. And cross-border rail is really, as Lars now mentioned, a cooperation where we become more connected. And it's really about different infrastructures, different rules, and different systems that needs to be working together seamlessly. So the demonstration we will see will show how digital tools can automate coordination and improve capacity management. So let's start the session. Welcome Magnus Valborg, who's been responsible for the development in the cross-border operations. And now we are really curious about the solutions that you have developed with your team, from participants and from different countries and organizations and stakeholders. So let's begin.
Thank you, Linda. My name is Magnus Valborg, leading Flagship 1 from Trafikverket, and I will lead this cross-border part for today. And we have 7 demos, and you can find the posters of all these 7 demos at the Europe Rail homepage, Flagship 1 MOTIONAL. Capacity and traffic management. Capacity management is to plan trains and track works, and traffic management is to control and dispatch traffic and to handle disturbances. And what is ongoing is this with federated European capacity and traffic management. And for this, it's developing federated European methods and tools. Though still the main intelligence is in the decentralized European national systems. And then we also have this with the capacity regulation, and we also have an ongoing process with this implementation of this new process with TTR timetable redesign. And in Flagship 1 Motional, we have 7 cross-border solutions that have been demonstrated. And the main organizations or the involved organization are Trafikverket, Jernbanedirektorat, Siemens Hakon, and Mermek. And we also have a special focus on the corridor Malmö-Oslo-Alnabru, where we have demos both in Flagship 1 and Flagship 5. And there we also have railway undertakings and stakeholders involved. We had a one-day cross-border event, 13th of May in Stockholm, and there we had all of these 7 demos presented. And in the afternoon, we had a wider dialogue about the topic for cross-border. And we also had a panel discussion. Our first demonstration and solution is cross-border planning from Mermek. And what they have developed is a solution for between local capacity management system and RailNet Europe path coordination system. So for a request, a path request for cross-border, they have then made a solution that they can have an automated integrated solution in between 1 to 10 seconds. And this depends on the size of the network and also about the request by the operators. And the conclusion is also that this then is effective and consistency, and it's this kind of automation that we see the need for the future. They have also followed the specifications from System Pillar, and we see it as a scalable European solution. For cross-border planning and operations, we also have demos from Hakon. We have 2 demos for cross-border planning and 2 demos for cross-border operations. And for this, we have a film that we will show. So please show the film.
European rail infrastructure operates as an interconnected network. Yet systems fragmentation remains a severe challenge to effective European cross-border and cross-area rail planning. Infrastructure managers need software tools that are precise, reliable, and future-ready. Connected systems are fundamental to enable intelligent and seamless cross-border capacity planning and railway operations. The foundation of our approach is the bidirectional exchange of train path data using telematics TSI messages. Besides the bidirectional system-to-system integration with RNE PCS, via both the PCS integration platform and telematics TSI common interface, TPS also supports direct data exchange with neighboring systems to enable joint planning. This exchange is a fundamental feature for fast, high-quality, reliable cross-border capacity planning. Hakon is a Siemens company specializing in railway software development and consulting. Our suite of products addresses the full spectrum of railway planning and operational needs. The TPS suite of specialized products offers several purpose-built innovations that provide seamless, intelligent, and largely automated workflow. Doing capacity management in a single, cohesive planning environment eliminates the inefficiencies of disconnected systems, ensures that every planning decision is grounded in accurate, period-specific data, and equips infrastructure managers with the precision, transparency, and confidence they need to manage capacity effectively. All the products in the TPS suite are modular and interoperable. Considering the brownfield situation in Europe, our products can exchange information via system-to-system interfaces, even with systems supplied by other service providers, provided that those systems satisfy the minimum standards for interoperability. Consequently, any of the systems in the diagram on the left side of the screen can, in theory, be substituted by alternative systems. It is important that there must be proper exchange of information between systems, not only within a country but also across borders. The diagram on the right illustrates the standardized high-level flow of information in the federated systems model in a cross-border scenario. Planned or executed changes on one side of the border are automatically shared, imported, and applied, and an automatic recalculation of all affected trains is done, including conflict detection. TPS Plan's timetable optimization model applies intelligent optimization algorithms to automatically resolve conflicts, producing the conflict-free timetable. Optimization algorithms consider the full complexity of the network, producing solutions that a manual process would struggle to match in speed or quality. Considering the evolving TTR landscape, TPS Plan can export capacity model data in a structured ECMT-compatible file format, ready for direct upload without any manual transformation. More information about new features like the train path envelope, capacity bands, and infrastructure versioning, supported directly in the TPS user interface, has already been presented at the cross-border dissemination event. The TPS Plan Sandbox features provides planners with a fully isolated environment to safely perform what-if scenario planning. And the entire cross-border data exchange, automatic recalculation, conflict detection, and optimization workflow is supported across all planning horizons, from strategic multi-annual planning down to very short-term operational adjustments. We now shift our focus to the operational perspective. The connection and integration of a federated traffic management system solution would equip traffic managers on both sides of the border with a common operational picture, which would provide the necessary situational awareness to support the effective management of international services. TPS Live is the traffic management system in the TPS suite of products, designed to provide real-time monitoring and operational control of train movements across a defined railway network, and was consequently the basis for our cross-border developments. TPS Live maintains a continuously updated operational forecast, recalculated in real time in line with replanning actions and the actual movements of trains. TPS Live generates an optimized, conflict-free operational plan for the next 2 hours within a maximum computational time of 20 seconds, even for highly congested timetables. TPS Live serves as an efficient and reliable tool to support dispatchers in their everyday work. It delivers faster response times, optimized infrastructure use, and highly robust traffic management. The continuously updated operational timetable maintained by TPS Live serves as an authoritative data source for third-party systems. System-to-system interfaces automate the sharing of operational data, where the end-to-end flow of information is automated and continuous. This approach ensures that all role players have shared situational awareness based on reliable real-time data, and the need for and reliance on manual communication and manual data transfers is minimized. TPS Live is built to scale, and its architecture supports integration with neighboring systems, making it a capable solution not only for domestic traffic management, but also for cross-border operational contexts. In our approach, the necessary connections are done directly within the national traffic management system. This approach keeps the working environment familiar and straightforward for traffic managers. Each national traffic management system extends its infrastructure model across the border to the first major station or significant point on the neighboring network. The entire border region is clearly visible, and trains approaching the border from either direction are visible to both the sending and receiving traffic management systems. The continuously updated forecast is automatically exported to the neighboring traffic management system, which uses it to maintain accurate knowledge of the train's expected arrival at the border location. As a train crosses the border and its real-time position becomes available, the transition from forecast-based to position-based tracking is seamless. The bilateral exchange of information also extends to temporary capacity restrictions. A TCR created in TPS Live is made available via an interface to neighboring traffic management systems and other third-party systems. Traffic managers and dispatchers can see restrictions behind the border directly within their own operational interface. This creates immediate awareness of the restriction and the impact on trains. Modern railway operations depend on the seamless flow of accurate, timely information across planning and operational systems. The TPS suite of products demonstrates how integrated software systems can establish a continuous, automated information pipeline from strategic timetable planning through to real-time operational execution. By automating the end-to-end flow of information from long-term planning through to real-time passenger communication, the TPS suite demonstrates a credible and scalable pathway towards more resilient, responsive, and coordinated railway operations.
Okay, and then our next demo is coordinated yard planning with YCS. And this is for Malmö arrival departure yard. And the method is to share information about current status and plan. And what we're doing there is to go from telephone to digital information with optimization functionality and a well-developed user interface. And this gives us then increased transparency, better working environment, but also most important is that we get this system view about current status, so we can have this interaction with the network and the node. And this is, we are going for higher TRL in wave 2. And here we also have a film, so please.
Rail freight is essential for a sustainable transport system, but busy freight yards are complex environments where many actors must work together in real time. Today, planning and coordination are often fragmented, especially at cross-border rail freight yards such as the multimodal Malmö freight yard, an important node in the Scandinavian-Mediterranean cross-border corridor. Infrastructure managers, terminal operators, service providers, and railway undertakings often rely on separate tools and disconnected processes. This limits coordination across borders and between actors, leading to inefficient use of tracks and terminal capacity, operational conflicts, reduced punctuality, and increased costs along the corridor. YCS, the Yard Coordination System, is a digital planning and coordination tool developed within Shift 2 Rail and Europe's Rail. It enables shared planning, real-time data exchange, and coordinated management of activities in rail freight yards, bringing together yard managers, terminal operators, and infrastructure managers in one collaborative system. With a common operational view, all relevant actors can coordinate track usage and yard activities more efficiently and proactively. YCS also strengthens the connection between yard planning and line planning, improving traffic flow and operational coordination across the wider rail network, including along cross-border freight corridors. By supporting proactive and coordinated decision-making, YCS helps make railway operations more efficient, resilient, and robust. Let's look at an example. A train will be arriving late at the yard. This creates a conflict for planned track usage. With YCS, users can immediately see the impact, evaluate alternatives, and coordinate a new plan together. YCS also offers an automated conflict resolution function to solve arising conflicts. Track allocations are updated, resources are replanned. Operations continue with minimal disruption. YCS has been tested, demonstrated and validated for common disruptions for the cross-border rail freight yard Malmö in a simulated environment. The Swedish infrastructure manager Trafikverket and yard service providers Green Cargo and Mertz participated in the validation. The validation showed that YCS can provide many benefits. Benefits include better use of yard capacity, reduced disturbances, improved working environment for traffic controllers and yard staff, improved punctuality, resilient and robust operations, including cross-border traffic, and ultimately more competitive rail freight. YCS is a step towards digitalized and smarter rail freight operations, better coordination, better flow, better rail freight.
Okay, and then our next demo is a decision support for cross-border train path using residual capacity. And the demo have been used for long-term or ad hoc planning from Oslo, Alnabru down to Malmö. And it involves both optimization and simulation. And the results for the evaluation is very promising. So problems that today takes 1 day to solve can be solved in 10 to 30 minutes. And also that the decision support gives several alternatives, and also with simulation can give the impact. And we had very good feedback from the users, so we have good input to the next wave, and this will proceed. During Flagship 1 Emotional, we have also had regular dialogue and cooperation with the system pillar Task 3, capacity management, traffic management, about specification and demonstration in Flagship 1, and about specifications in system pillar. And this slide shows the overview about the traffic control. With at the upper part, you have the national capacity management system, traffic management system. And then you have interaction with European supporting tools for CMS and TMS. And then you have integration layer down to traffic and control and supervision. And here you have also this with ATO trackside. And at the lower you have the trains with the ERTMS lines and the Class B lines. And for Class B, this with the CDAS trackside is relevant. And for Flagship 1, we are focusing on the upper part, but also this with the connection to CDAS and ATO. And in Flagship 1. And in Flagship 2, their focus is at the signaling part and the lower part. This slide shows the summary of Flagship Motional Wave 1 cross-border part. And the first result was this from Mermek with a direct automated integration with capacity management systems and this RailNet Europe path coordination system. And then we also had this solution for cross-border train path using residual capacity. And the third result is this with improved station yard planning with this YCS. And this gives us the capabilities to have this overall system view, and then we can have this real-time alignment between a node and the corridor. And then we also had these demonstrations from Siemens Hakon with enhanced communication and coordination between a traffic management system and CMS and TMS cross-border. And the last result is this with improved feedback between TMS and back to CMS. So we are following up this. And to the right, you can see what have been improved. And it's, of course, then very much is this about capacity, better capacity methods that increase capacity, but also that our methods increase the capability for flexibility. And with connect capacity management, traffic management, we get higher quality, but we also get better knowledge about the KPIs and how things is connected. And this capability also gives us the puzzles to increase robustness and punctuality. And everything is to work in a collaborative way and in a dialogue with the System Pillar and RailNet Europe. So this harmonization is essential, and very much is about how capacity should be utilized. And then we have this with infra manager, railway undertakings, and then to be close to the customer needs. And we are also having some plans for the future work in Wave 2. And here we are more also working more together. And Lars, do you want to say, take this one?
Now, in fact, what is important is that for sure Motional 1 was the first step in, and we mentioned already, for example, the TTR-related functions. So TTR as a, in brackets, new concept is something which is evolving, and all the national systems have to be prepared. So it's a continuous work, and which we will extend more and more. So to enable that the national systems are really in this new, more European concept, really fit together, can work together, so that at the end we can really achieve the major improvement which is foreseen with TTR. And it's a real shift. It's totally new. So, and projects like Motional are the right ones to test things, to bring new functions into the market which are needed, and then together with R&E to work on the interaction between national and central systems and to bring this forward.
Yes, indeed. And now with the capacity regulation, you could even, it's like 4 years ago when you started Flagship 1 and the program, it's like they already then thought about the outcome of the capacity regulation, because the pieces fit so well together, doesn't it? And to fulfill the capacity regulation, the new way of planning earlier, in new ways, elements like rolling planning and strategic planning of capacity, and also smarter way of working. It can only be done with smarter solutions, also the digitalization. Otherwise, it will be truly challenging, if not impossible. So it's so great that when the capacity regulation arrive, then also the smart solutions are being served by Europe's rail.
Yeah, and it's so important. It's a very good point because rolling planning is a good example. So we worked on rolling planning in Motional 1 already, and it's important that whenever the national systems, which let's say have to do a significant investment in providing these new functions and covering them in a proper, unique, or at least interoperable way for cross-border topics, this is something which should not be underestimated. It's a complex, let's say, development in existing systems. which needs to be done. And this is really what I'm looking for in future, to really implement it. And for sure, 4 years ago when we wrote the proposal, we had the capacity regulation TTR in mind.
TTR was
but it
already
was
on its
not
way,
clear what is exactly in and how it is in.
Yeah, and
And
that
that's
is why
why-
it's so helpful, because I mean, the research is all really about thinking out of the box, and then give us some ideas, and then we can pick the best elements and ensure that it also works in practice, and that it comes into the rollout plans of each infrastructure managers. But here it's not only a teamwork between you, which have been brilliant, but also the sector. It's so many stakeholders involved to make this work, isn't it?
Yeah, and the sector needs to act as a family. So I can only repeat it, because if we are not working together, the challenge is just too huge to do it alone.
Yeah, indeed. And then RailNet Europe would have the systems, the processes, the routines, and how to manage the capacity. European Railway Agency will have the registers of the infrastructure and the basis for how to use the infrastructure in the best way. And of course, railway operators with their informations and the terminals and ports and so on. So there are so many involved in making this happen also in practice. So, thank you so much for this first start of the technical sessions. We were in the operational field, and now we will move on to the intelligent planning session. So now we are looking what is going on behind the scenes when we are planning for capacity, and how this can be done in an intelligent way. So with us now we hopefully have Christel from Paris.
Hello.
Yeah, hello.
Hello,
Great
Linda.
to see you.
Hello, everybody.
Yes.
Hello from Paris. I am Christelle Lérin from SNCF. I coordinate SNCF activities in FP1 MOTIONAL. And we were honored to organize and host the Intelligent Planning Dissemination event in Paris on the 12th of May. And I think it was a successful and appreciated event, yes, very rich. And so now to fully understand what intelligent planning encompasses, let's listen to an excerpt from the introduction given by Magnus Valborg from Trafikverket, who is leading the subgroup Planning and Simulation.
My name is Magnus Valborg, and I'm leading Trafikverket in Flagship 1 and coordinating this subgroup 1 capacity planning. So it's very nice to be here in Paris for this intelligent planning event after 3.5 years of hard work to see the results. In capacity management and traffic management, intelligent planning, boosting planners' power with smart algorithm and simulations. We have 27 demos, so it's quite many demos, it's most demos. Because what we are doing is that we are covering a very important area. And we are also doing it with the different methods and approaches. And for this decision support and optimization with decision support algorithms, the focus is this with long-term and short-term planning. And we are having these innovations with decision support algorithms, and these decision support. It's very important that we are working in contact with the users, because the decision support gives the users new possibilities to solve problems and also to solve problems that they cannot solve today. So this interaction with decision support and users is important. And it's also important to have the wider perspective, so we see how this connects to other processes and automations and improvements. The other area we will hear about today is the simulation and operational feedbacks, and that very much focus on new technologies. And then, of course, it's this with the ETCS, ERTMS implementation, and also this with the CDOS ATO, and the feedback loops from operations to planning. And I know we have very many very important demos in this area.
As Magnus mentioned in introduction, the intelligent planning scope covers 27 demonstrations, focusing on long-term and short-term planning, as well as performance simulation of new technologies. Of course, we can't present all these demonstrations in detail today, but I hope to give you a good overview of the work accomplished through the pictures of the demonstration posters.
My name is Klaas from Hakon, and I present the poster on integrated planning. So it was, we connected a CMS, a TMS, and a yard system, and exchanges via telematics TSI, of course, messages between the systems to ensure that other systems are informed in time and have time to replan, to replan something. And we did this with our TPS suite, of course, and we can showed some quite good results that helps to increase efficiency, of course. And it's as I said, integrated in our products, and so a quite good approach, I think, for integrated planning and the seamless planning.
Okay, so we use sophisticated techniques from mathematical programming, discrete optimization, and graph theory in order to develop a new efficient optimization algorithm for short-term timetabling. And we integrated this algorithm in our powerful TPS plan. So if you need, for example, to mitigate the effects of temporary restriction or insert a new train in an existing timetable, or for example, for any reason you need to temporarily change the route of a planned train, then you can use our tool in order to produce new conflict-free and optimized plans that minimize the differences with the original timetable together with the total delay of the trains. And so if you're interested in increase the capacity of the, please visit our poster session. Thank you.
Yeah, thank you. Our work deals with optimization for long-term strategic timetabling, which goes from a passenger-oriented network timetabling step from scratch, essentially, to then fixing possible conflicts in that timetable on a mesoscopic level, and finally validating and improving how that timetable could be operated in a station. This is a collaborative work of Erasmus University and NS, as well as SINTEF and the Norwegian Railway Directorate and the German Aerospace Center. And we're very happy to present results both on the individual algorithms as well as how they can be used to in a decision support planning pipeline in the end then. Thank you.
So good morning, I'm Dennis Huisman from NS, and actually François told this morning that in France there was the aging infrastructure and a lot of maintenance work, and actually you see that in many European countries, also in the Netherlands. So this poster will be about the decision support to let's say limit the impact of all this maintenance to the passengers, and how can we adjust the timetable in a passenger-friendly way. So if you're interested in that, come to my poster and we will talk about it further.
Hello, my name is Enrique Gomez from Indra. And in this case, timetabling often requires to have the application of conflict detection or resolution. We want to put a new possession, we have to put a new temporary speed restriction, and through this conflict detection and resolution, based on genetic algorithms, we have achieved a better timetable. On the right, you can see that we have a dashboard that indicates all the KPIs or the fitness function, that it is a combination of all the KPIs, and we know that in each iteration we get a better result. We have used Estonian Railways network data and timetable from there. In this time, we have this capacity analysis of different signaling systems. So we have improved, we have enhanced our capacity analysis tool. So using also the Estonian Railways data, we can measure with headways, with total running times, other issues that allows us to know that we increase the capacity. We have also a replay function on the right that we can simulate all the trains that we have achieving that. And we have tested with ETCS level 2, and we have included several virtual signals, virtual blocks, just to generate that. In this case, we have a simulation environment in Indra, and in this case, we have included the possibility to launch simulated trains based on the CDAS instruction. So we have the synoptic view. In this case, we include one or several trains with CDAS capabilities and simulate if we increase the capacity, not the capacity, but the operational capacity in specific scenarios. So we have checked that moving this, there are specific scenarios and we get more information or more not capacity, but we have better timing in this way. So that's all from myself.
Hi everybody, I'm Dario from Hitachi Rail, and our poster will present the job that has been done by Hasan at Hitachi Rail and by Sintef. The tool is basically an integrated HMI that allows a planner to deal with TCRs, with capacity restriction. It has a dashboard for KPIs, and you will see better the face if you come see our poster. And yeah, that's it.
Hello. So we made a very simple and cool, I think, tool for rolling stock planning in the case of strategic timetabling. So you want to build a new timetable for the next 5 years. You want to know how many rolling stocks you need. Then we make this web-based tool. You can just like drop in basically an existing timetable, press a button, and you will get in a second the rolling stock rotation, the optimal one, minimizing the headaches, train unit types, but also minimizing passenger discomfort, as in number of passengers that are standing on average. And the cool part is that you can also draw more trains in this GUI and see how the rolling stock rotation changes. Thanks.
Yes, so I'm here on the behalf of VTI. So here is a different type of simulator. This is a train driver simulator with a bit of eye tracking. So here they evaluated different ERTMS rollout strategies on a line in Sweden, and that require different type of driver interactions. And then you can, at the same time, they had different obstacles. So here you can see bicycles to the right, but due to the driver needed to focus so much on the in-cabin, he or she could not identify the bicycle rider to the right there. Yeah, there was not a picture there, but here's a large-scale simulation that is with an tool developed by DB, but also together with KTH, the University of Stockholm. And here we simulate a large network where we see different primary and secondary delays, a bit like Axel told in the beginning. And we had a methodology how to distinguish them and to control them with empirical data. So, thank you.
Hello, my name is Saga Strelius, and I am going to present sort of like the usability aspects of optimization and long-term timetabling, so taking or making the annual timetable. And I will also talk this afternoon, so come speak to me at the poster, or I will speak this afternoon. And I'm also here to present work done by Mikael Fredriksson, Carl-Henrik Hell and Emma Solinen, and they have looked into a method for supporting changing a timetable for TCR, so temporary capacity restrictions, in sort of like the time period where you have a few weeks before you have your TCR. And as a sort of a little bit of a teaser, I can tell you that the planners did not really know what they were supposed to do, but they really wanted a tool to help them. That is what the results show. So it's interesting.
Hello everyone. So I'm on behalf of SNCF Research Department and Mines Saint-Etienne. In demo 7.6, we developed an algorithm that applies minor modifications to existing timetables to unlock additional capacity for last-minute trains. It's based on the open source railway designer environment, simulation environment, and the subsequent last-minute request tool. So if you want to know more about our algorithm and all of this, so you can come to our poster in the corner at the entrance. Thank you.
So I'm Jörg Boejenk from NS. So we have a solver that solves the shunt yards, the plans of the shunt yards, which involves all the details. So at every point of time, we know where each train is, where each train driver is, and what he's doing, what they're doing. We have a solver. It's live. It's in production, and when on the smaller nodes. And what we did for Motional is to extend the solver to improve it, such that we can also support the largest station areas, such as Utrecht Central, which is the largest station in the Netherlands. We also have a computer with us showing the GUI, and you can play around with the in-house developed GUI showing one of the plans. Yeah.
Yeah, so what feeling does this image give you? For me, it gives a feeling of, I'm too late. It's fear, I'm going to miss my train. And weirdly, our train drivers and guards know this feeling as well. They can be late because their first train is delayed, and they might miss the second one. Now, there's good news for them. Ricardo, Luis, and I have found a solution for this. You can learn all about it at our poster. It's a bit on the right, so grab a drink and then come visit us.
So in our demo 9.8, we are proposing a new planning tool to get optimized planification and to improve the capacity of the line. That's all. Thank you.
Okay, we have worked on the interfaces between the integrated asset management system, the TMS, and our future autonomous inspection vehicle. So we have worked on the interfaces, the message interaction between them, and we have thought about which information needs to be exchanged between the different subsystems. So we have the poster in the entrance, so you can visit us later.
Hello everyone, I'm Sveva from Trenitalia, and our demo includes two use cases. One about prediction of punctuality in advance, and the second wants to improve the number of connections. That's it.
Hello, my name is Pieter Jan from NS. My poster is all about rolling stock, algorithmic support for rolling stock dispatching. This morning, Timon mentioned that since 1996, NS is to a large part responsible for scheduling, because we can have a good focus on passengers. And if you are interested in how we finally implemented this focus in rolling stock dispatching, come discuss at my poster.
We were fortunate to have a roundtable discussion featuring executives from SNCF Réseau, François Marchal, from NS, Timon Vogt, and Magnus Warburg from Trafikverket, moderated by Isabelle Tardy from Norwegian Railway Directorate. So here's an inspiring excerpt with key terms such as cooperation and open source.
I think today we are coming very much into this with our demos and the validation events and how it is accepted by the users. And a result, as I have seen it, is that results from demos affect the users, and the demos make us possible to solve new problems that have not been possible to solve before. So when we doing these demos, then we can solve problems in a higher level. And I think it's very important, and it's a very good combination with working with the users and have researchers, because I think that's the way how to do this progress, and I see steps in this direction. Another experience from Trafikverket is that we have had quite a long step between infra manager and system suppliers. So we have made very huge projects specified with the infra manager, and they have not been so successful. So this working closer infra managers, railway undertaking, and system suppliers, and more interactive approach, I think that is very important.
Well, I think what you just said is some sort of an example of that. Is by sharing knowledge, by don't be too contractual towards each other. Of course, we have to make good agreements on how we work together, but the open source mentality that you mentioned, I think that's something I was really inspired by that. I think we see each other too much as competitors, as working in the same field, and it might be something that is left of the 90s, where we all thought that we would be the biggest railway company of Europe, and would run trains in other countries. But I think most of all we are colleagues in the same industry. So I would hope that that we would do more open source, that we will share more insights, and that the people in Scandinavia are working together with the people in Southern Europe. So I was really inspired by all those examples today, and it's what makes me so proud of the railway sector, that it's sometimes one big family, and we try to work for the same goals. And last year, sometimes the more legal way of interacting has become the standard. But I hope in our work of field that we just, with a lot of energy, work together and make the best as we can. Yeah.
I completely agree. Yes, we well, the real competition for railway operation is more carbonated mobility. So we have the opportunity to run the decarbonation of mobility. Well, there is something to hopefully with electrical motion on road as well. But well, we know that it's well efficient in energy. So that's why we have to be together with the European Commission and on all these stakeholder to be sure to put a future of mobility with less carbon, and ensure that the impact of climatic change is not too awful for us. So yes, cooperation, standardization is absolutely necessary, and it's a good example of with all the projects presented to enforce this regulation, this cooperation.
It's time now to hear the closing remarks from the leaders of Work Package 7 and 9, Dennis Huisman from NS and Per Kohler from Trafikverket, and the leader of Subgroup Planning, Magnus Walborg.
Yeah, hello, and Dennis Huisman. from NS, work package leader of the work package in decision support algorithms for timetable and railway planning. And we just have seen a great video about all the results that we got in this work package. I'm really proud on all the work that has been done. We had 10 different demos on long-term timetabling, on short-term timetabling, and on rolling stock planning. I think we delivered some great results that can improve the railway operations in Europe.
And we are seeing that we can increase the capacity and the punctuality in the railway system without building new infrastructure and by using current infrastructure more efficiently. So I look forward for further collaboration between our different partners and colleagues in Wave 2 for further development of our capacity simulation models. Thank you.
Intelligent planning in Paris. We have heard about 27 demonstrations, and for myself I have got lots of positive energy, and it has been high quality and interactive. You can feel the energy in the room. And this is the first wave, so then it's a strength to have 27 demos in intelligent planning. We have built a good ground for the next wave, where we have more integrated demos. And what we are doing is building knowledge together. And yes, I have a lot of positive energy. That's the summary.
So now we are back in the studio in Stockholm and in Paris, and I apologize for the bad sound in the end, and I hope everyone was able to hear what was said in the end. So, Christelle, it's quite comprehensive results there, around 27 different solutions. Could you summarize a little bit about what have we seen here? 27 solutions.
Yeah. Yes, thank you for the question. It's a difficult exercise because, as you've seen, 27 demonstrations and results are very rich. But what can I say first is that the results show that advanced optimization algorithm can play a major role in tackling various timetabling and rolling stock planning problems. In this way, throughput times of the planning processes can be shortened, and most scenarios can be studied by the planners, the same number of planners. And of course, this will result in better timetables, both for passengers and freight, and more efficient rolling stock plans. And as a key outcome is that advanced simulation tools give us deep insights into how next generation railway technologies impact network capacity. I talk about GCS level 2, hybrid trend detection, and systems such as CDAS and ATO. And the demonstrators show that, for example, hybrid trend detection offers substantial potential for increasing capacity where infrastructure allows, while CDAS and ATO improve operational robustness. And also a key finding is that the greatest benefits arise from the combined application of this technology rather than from one individual solution.
Yeah, and would you say that all of those innovations that you showed and demonstrations that you showed are they ready to use in operational use?
Now we can say that the conclusions of the demonstrators are very promising, of course, but there are still preliminary. Most algorithms are ready to be pushed to validate at a higher technical readiness level, 7 or 8, which is a necessary step before they can be used in actual planning processes. And in addition, instances of larger scale need to be solved to make the algorithm applicable for the most complex and thus most relevant practical timetabling and rolling stock planning problems. And these challenges will be tackled in the subsequent waves of Europe's rail.
Yeah, so great. You really illustrated here that with the digital twins, the smart way of working, the digitalization, that the capacity planners can really use this. They will have several options and then take smarter and better decisions. So we will improve the rail services and the offer of rail in Europe. So thank you so much. And
thank you very much.
Tonight, Christelle, we have something exciting also in front of us. Sweden versus France in soccer, in football. Looking forward to that game. Yeah, I will watch it, and we both have really good teams, don't we?
Yeah.
Yeah. So thank you so much.
Thank you very much.
Now we will move on from the capacity planning and back into the operational field again to the real-time intelligence session. So now it's time for the real-time intelligence session. This is about predicting what should happen to better be able to manage what actually happened in real time. So it's a little bit looking into the future, but in short time. So I would like to warmly welcome Christian Esposito, who will present the results of the real-time intelligence result.
Hello everybody, and thank you for this opportunity. This is Christian Esposito from Hitachi Rail. I'm the leader of the SG2 that actually encompasses work package from 10 to 18. And we have been working on the real-time intelligence, so the application of artificial intelligence and automated control within the railway to deal with the various problems of conflicts or failure management or even more disastrous events happening in the railway infrastructure. In the next videos, we will have a little set of the demonstration that we had from work package 12 up to work package 18. We had 26 demos that we presented in Poland. This video will give a glimpse of what we have done in the subgroup 2.
Within the current railway infrastructure in Europe, we are witnessing a growing increase of complexity in terms of increasing traffic density, increasing number of connections, increasing number of services provided to freight and passengers. Europe is investing a lot of efforts to boost the railways, but of course this is posing insignificant pressures on dispatchers, controllers and train operators. More and more the infrastructure is affected by failures, conflicts and even deliberate attacks during the Olympics or major international events. Railways represented a target, and actually these three events can cause service reliability and safety to be reduced, and we are witnessing increasing delays and missed services to passengers. The solution to improve the current infrastructure is the further digitalization. This allows to efficient, robust, intelligent infrastructure to harmonize the various architecture and entities all across the Europe and implement the possibility for cross-border traffic management. Within the promotional project, we have worked on the design and realization on a number of solutions that actually can be represented in 4 core ideas: a closer coordination between traffic management decisions and automating trains operation, a continuous interaction between planning and real-time operation, an improved decision support mechanism, and automated operational procedures, lowering the cognitive workload of controllers and operators using it, an AI-based solution to detect and resolve conflicts earlier within a human-in-the-loop approach. The SG2 actually encompasses the realization of 26 demonstrations across the work package from WP12 to WP18. Those demonstrators have been indeed presented in the demo dissemination event held in Morland, Sweden, in 27th of May that attracted professionals, researchers and stakeholders from 13 European countries, and they presented the latest developments in terms of real-time intelligence, automation and support for the decisions to handling failures, attacks and conflicts within a railway infrastructure.
In this world of rising energy costs, optimizing energy efficiency in train operations is more important than ever. Traditionally, train drivers focus on punctuality, often overlooking energy consumption. In Motional, Hitachi Rail has developed a solution that processes the latest timetable and calculates, for each journey, an optimal energy efficient speed profile. The optimal energy efficient speed profile allows to generate a detailed timetable. The detailed timetable is seamlessly communicated with the ATO trackside via the integration layer, then interfaced with the ATO on board using subset 126 according to CCS technical specification for interoperability. The result? Reductions in energy consumption without compromising train punctuality.
Today, most traffic management systems operate as isolated systems. At control boundaries, visibility is limited and coordination often relies on manual communication, leading to late conflict detection and inefficiencies. Our approach enables cooperation between neighboring TMSs while keeping them independent. Systems exchange key information, conflicts, forecasts, and resolution proposals in real time. Decisions remain with operators, supported by a structured workflow to accept or reject proposals. We validated this using 2 TMSs on adjacent railway sections, connected through a cooperative interface and real data. Results show faster coordination, earlier conflict resolution, reduced workload, and improved efficiency, especially valuable for cross-border operations.
The demo 14.1 is being developed by Hitachi STS during the context of the work package 14, and is about collaborative decision support system for disruption management. The current situation of railway infrastructure is characterized by a segmentation in multiple fragments of control, each one collecting data and having an operator to decide what to do in terms of maintenance or rescheduling of the railway traffic when there is a failure, disruption or an attack. The communication among these operators is extremely difficult, and they represent island of control as they do not coordinate among each other. Each operator has a manual decision making, looking at the monitoring data coming through the machinery, and based on their experience they can decide what kind of activity to trigger in terms of maintenance or rescheduling. Of course, as soon as the complexity and volume of traffic is increasing, such a fragmented and manual management do not ensure proper level of safety and timeliness within the infrastructure. It's better to have a more coherent and optimized approach where actually we have a centralization or a multi-actor coordination with a DSS that automatize the decision process within the operator center in order to have highest safety safety possible to minimize delays and to enable proactive, risk-informed infrastructure planning. Within the context of the demo, we have emulated the railway failure. We have demonstrated how the system is able to present to the operator the best set of actions to be triggered in order to properly countermeasure the occurred event. During the demonstrator, we have collected a number of stakeholders, trained them in the first day, and allowed them to use the solution in the second day. In the HMI, each user has its own identity and role. This is important in order to profile what kind of information each operator has to receive so that the HMI will fetch from the integration layer only what is needed. As soon as the user log in, we can see immediately the fetching from the integration layer and the presentation of possible alarms. In this case, a track circuitry warning, where we have the actions to be done. Especially at the beginning, the DSS suggests to check the monitor values to understand if it's out of range or within the nominal range. Based on the output provided by the user, then we have the follow-up task within the procedure to handle the track circuitry warning. Then the operator can follow the tasks, start entering the alarms and the information, planning maintenance as well as rescheduling of trains within the infrastructure. The list of activities is dynamic and depends on the interaction with the operator. In case of scheduling, the operator can plan the scheduling procedure within the segment that actually manifested the alarm, check the details of the procedure, and interact with the maintainer in order to understand if the operation has been done or not, and actually call the operator through a voice call in order to have a direct interaction with the maintainer and have more information out of this interaction. When everything is completed, then the alarm is no more manifest within the HMI and the operator can pass to others. Alarms are prioritized in order to provide low cognitive workload to the operator.
This demonstrator presents RailvoSim, a simulation platform developed to test how railway traffic management systems communicate with CDAS solutions. Its main value is that it recreates, in a safe and controlled environment, the behavior of multiple trains, their traffic plans, and the real-time exchange of information between trackside systems, onboard systems, and the TMS. This helps validate that data is exchanged correctly, trains follow the planned operation, and key information such as position, speed, and arrival forecasts is sent back to the traffic management system to support better decisions. The demonstrator was tested using real RTTP data from the Civitanova-Albacina line in Italy, with train movements visualized through a real-time dashboard. With RailvoSim, the development of digital railway solutions is accelerated, and future deployment of CDAS and ATO systems becomes easier. In short, this tool brings railway innovation closer to real operation, making the network more efficient, reliable, and ready for the future.
Railway operations increasingly depend on efficient coordination between traffic management systems and connected driver advisory systems. However, when real-time updates are not available, operational efficiency can be affected. To address this challenge, we implemented an integration layer and interfaces to enable bidirectional communication between the systems. During the demonstration, Indra tested the exchange of real-time traffic plans and status reports between the TMS and the CDAS trackside. This confirmed that both systems can continuously share synchronized, up-to-date information. The solution was demonstrated using real infrastructure and timetable data from Estonian railways. The tests showed consistent message exchange, low latency, and effective data storage and transformation. This demonstration confirms the effectiveness of interoperable communication between TMS and CDAS, providing a stronger foundation for connected, data-driven, and more efficient railway operations across Europe.
Demonstration 16.7 TMSATO integration evaluates the performance of the integration layer to dynamically interface ATO trackside and traffic management system in a real railway operational environment. This data exchange is important for real-time traffic control. The ATO onboard reports all the events to ATO trackside, which are then transferred to the TMS. The TMS can evaluate the data and send a journey profile update to the train if needed. The communication is event-based. The integration layer was tested on a test track under ATO GOA3. The tests considered real-life conditions with simulated disturbances and delays. The outcomes from this demonstrator show the possibility of using a universal interface between the ATO and TMS. Demonstration 16.7 TMSATO integration evaluates the performance of the integration layer to dynamically interface ATO trackside and traffic management system in a real railway operational environment. This data exchange is important for real-time traffic control. The ATO onboard reports all the events to ATO trackside, which are then transferred to the TMS. The TMS can evaluate the data and send a journey profile update to the train if needed. The communication is event-based. The integration layer was tested on a test track under ATO GOA3. The tests considered real-life conditions with simulated disturbances and delays. The outcomes from this demonstrator show the possibility of using a universal interface between the ATO and TMS.
Connected Driver Advisory Systems, CDAS, is an important concept to improve the train traffic, enabling better traffic flow and optimized energy consumption. However, if all trains don't have CDAS, there is a risk that the benefits of the system are ruined. Trains may get unexpected stops and unplanned waiting times, causing inefficiency and delays. The traffic controller uses the traffic management system to create and update the real-time traffic plan, also denoted the RTTP. However, when some trains do not have CDAS, even small delays may cause the real-time traffic plan to be inefficient. RTTP data helps traffic controllers make better decisions in real time. The tool analyzes train positions, predicts running times, and crossing possibilities. It then creates a proposed real-time traffic plan. The proposal is visualized directly in the traffic management system, making decisions faster and easier. The concept has been tested and validated on the station Åryd in Småland, in cooperation with VR, the operator of Öresundståg. The traffic controller sitting in Malmö used RTTP updater to adapt the plan for the actual traffic situation, including minor deviations. The train's crossings are operated smoothly, with no unexpected stops and minimal waiting times. Traffic controller remains in full control of the situation, and the benefits from having CDAS are realized. RTTP updater enables more efficient train operations. Benefits include fewer unnecessary stops, reduced delays, better punctuality, improved capacity on single-track lines, better support for traffic controllers, and smoother rail operations. RTTP updater is a step towards smarter and more efficient rail traffic management, better decisions, better flow, better rail.
As part of the Motional project, we investigated how real-time traffic management decisions can be translated into efficient train movements using ATO over ETCS. By integrating a train part envelope generator and the CAF ATO onboard system, into plural human-in-the-loop simulation environment, we were able to validate the complete interaction between traffic management and automated train operation. When traffic conditions change, conflicts between trains can arise, as shown in the upper graph. The tripod envelope generator automatically detects these situations and calculates if a conflict-free solution can be found by adding timing points. This information is sent to the train, which adjusts its speed accordingly, resulting in the conflict-free situation shown below. This demonstration shows how smart trackside support can help make future level operation more reliable and efficient.
This video presents our approach to automatic conflict detection and resolution in railway operations. The system enables real-time conflict-free planning within seconds, combining AI-powered decision support with full automation, not just predictions. A key feature is natural language interaction, allowing dispatchers to communicate directly with the system through a chat interface. The platform also supports what-if scenarios for training and post-event analysis. Importantly, the solutions are reliable, explainable, and easy to use, and they integrate seamlessly with existing traffic management systems as a plug-and-play AI module. In this short video, we show how natural language interactions, such as writing or saying "close track number 2 in Grafsen," trigger the addition of relevant constraints and the encourage computation of the optimal solution. The algorithm, based on mathematical programming, always returns the solution and minimizes total delay at destination, considering every possible configured solution among all trains for the next 3 hours.
ENISA's demonstrator for AI-based conflict resolution. The process starts with modeling the track layout from AutoCAD drawings. The AnyRail Graph tool allows introducing the elements that can be inserted, deleted, linked, and associated properties introduced and/or modified. Once the data introduction has been completed, database files are generated. A web-based graphical user interface is available. It provides dashboard to display KPIs based on previous runs. The system continuously searches for new conflicts. Those are displayed in different views, from the classical planning window to a tabular representation and the new route-based view. Users can select the conflict that needs to be solved. They are analyzed by the AI engine and different proposals are shown ranked to the users. Users can select them any or even none of them. Once applied, the new conflict-free planning is updated within the database, disappearing from the different views. As part of the development, a tool for generated conflicts manually has also been included. This allows modifying current planning, providing the facility to test different conditions. Additionally, it is also possible to create a set of tests that can be repeated. This has been extremely useful to test the evolution of the tool. Thank you very much.
CAF is proud to introduce an innovative traffic regulation solution designed to address the everyday challenges faced by railway operations. Throughout the day, minor disturbances can arise, leading to small but potentially disruptive perturbations in train schedules. To tackle this, we have developed a sophisticated mixed regulation algorithm that intelligently considers both the time of the day and the specific area in which the train is operating, whether in the busy center or in the quieter outskirts, recognizing that operational needs vary across different locations. This advanced approach empowers operators to quickly recover from minor issues without the need to reschedule the original timetable, maintaining a smooth and reliable service. Our demo showcases how this solution keeps operations on track, ensuring efficiency and minimizing passengers' inconvenience no matter what the day brings.
In the demonstrator developed at SNCF and Université Gustave Eiffel, our traffic optimization algorithm periodically exchanges information with the OpenTrack simulator replacing reality. So traffic evolves, implementing the decisions optimized always based on the latest available traffic prediction. With this demonstrator, not only we could assess our algorithm for solution quality, showing it allows strongly reducing delays, but we could also evaluate its speed, robustness, and suitability for real-time railway use.
We have
presented a number of demos developed within the context of the SD2. And we conclude this session by highlighting what is the feature of the work that will be done in the Wave 2. We have done a lot of experimentation demonstration, but we have planned for more large-scale scenarios where actually we have an increasing density of the rail traffic and the integration of multiple national railway domains in order to achieve a higher TRL level. Most of the solutions presented have a TRL 4/5. We have planned to go over that. We have worked on the data standardization within the context of Work Package 10 and collaborated with the system pillar in the standardization of the data model. In Wave 2, we will leverage on the era ontology model to further improve the standardization of the data within our demonstration scenarios.
Thank you, Christian. Quite a number of results you have shown us. And one thing that I'm really a bit curious about is AI. I mean, it comes more and more natural in our day-to-day life, but it seems a little bit scary when it comes to operations of train. Is it really that trustworthy to use AI in operations?
So when we think about AI, we are always a little bit scared about the consequences and the impact. In the Motional project, we start working on the feasibility of the AI to support operators. And we put always the operator on the center in accordance with the AI Act regulation within Europe. So the problem is not only to use the AI for the project, but how the interplay between the humans, so the operators, and the artificial intelligence solution. We have implemented HMIs to support this interplay, and we have put the operator at the center so that actually the AI is more a support to the operator to simplify also the mental workload, but not a substitute. So we are not going to substitute the human operators within the infrastructure, but to have a collaboration between the automated AI solution and the human experience in the operator.
Easy to know exactly where to draw the lines there, who is in control and to what level and to what extent we can use automation.
So the operator is always in control in accordance to the AI Act. We have human oversight. So all the decisions taken by the AI are always supervised by the human operator. And the human operator needs to identify what are the rules followed by the AI. So the AI needs to be explainable so that the operator understands the decision and can authorize or not the automatic outcome. So the person in charge here is always the human, and the AI needs to be supported and complemented by the human oversight.
Okay, thank you. Then I feel safe, also for the future. And thank you so much for Christian for sharing those good results. And I must say, so far, I mean, Europe's Rail Flagship 1 really is a success story, isn't it? It's really worth investing in those different innovations and exploring them. So now this morning we have went through the operational phases and the real-time intelligence, but also the intelligent capacity planning. And it's really not about replacing people, as Christian said. It's more about ensuring that people have better information and that information flows smarter and better and are better connected to make better decisions and smarter decisions for the future. And now, before lunch, which is ahead of us, I have now in the studio with me back Giorgio and Lars, and it's time for you to summarize this morning what we have gone through here. So I'm really curious and interested of your reflection so far.
Shall I start? Yeah, I think summarizing this morning will be difficult, but I hope we have not promised too much. It was a very interesting morning, and you have seen that some of the presentations were really squeezed down to some seconds. In reality, we could have talked hours about them, also with the details, and that is giving, let's say, a good feeling to see that we have achieved so much. There were so many developments going into multi-actor, automation, optimization, interoperability and integration. So we tackled more or less all the key parts, yeah, we hope it was interesting for all the participants in this call, and there will be more interesting presentations in the afternoon.
If I can complement a little bit, I would say on my side what I hope that we have been able to show this morning is that we can provide a superpower to the railways. There is a lot. There is a lot actually that has been demonstrated, and now we need to think of the next step. So the next step is obviously to continue to innovate, finding new, better way to superpower our railways, but it's also a matter of how do we implement all of this? How do we ensure that all the actors are going forward in a coordinated way? And you have already seen today that this collaboration, for example, with the system pillar on the standardization of the interfaces is already happening. But it's also interesting to see how some innovation create effect only if they are applied at system level by all of the actors. One example was on the CDAS. It brings advantages when connected with the TMS if all the trains in the network use this technology. So how do we facilitate this take-up of innovation, and how do we make sure that this is happening? And I think the best way is first to show that those innovations bring benefits, mission achieved, well done, and it's the necessary condition to reflect also on the next steps.
Yes. And maybe I can add on this, and you have seen it in some presentations that we tried already to use existing, let's say, brownfield products, which are implemented to show in a pilot demonstration how this innovation, either as a module or as a new function, could work. So even if it was then not in full operation, but it was really using the products which are implemented in the various countries as a basis, was so important, because at the end, if we have all these nice little developments with the algorithms which are brilliant, if they are not implemented, and implementation often, talking about infrastructure, comes through tenders from the national authorities. So this will be the next step to really check how the innovations can be brought into the products, into the tenders. So this will be very important. And the approach, let's say the easiest, is really to use products which are, let's say, well grounded, and to enhance them with these functions which we have now tested and shown.
Yeah, to create superpowers, there is obviously a need for Superman. And a superwoman.
Indeed, I think it's a collective exercise. I think this is important to highlight. There is no single person, but not even single entity that can achieve all of this. We need to work together, collaborate, and only by putting our brains together, only by, really pushing railway forward, and there will be period ups and downs. We're also doing research and innovation. From time to time we fail, it's totally normal, but only in this way we can advance, and yes, I think let's continue this path.
Good question.
Anything else to add?
Yeah. I'm just thinking about, because failure was a very good partner. So I think, why do we need these kind of programs? Because there's a lot which is not immediately paying off So for both sides, from the user side, from the infrastructure manager side, but also from the supplier side. So we need the room to jointly, and we learned it in some of the panel discussions, there must be a joint approach, which was not there in the past. So it was a lot they and we and so on. And we have to overcome this. But this also is a lot of effort, which normally the companies cannot really take care of themselves. And that's why to do it in such joint funding programs is so important in a collaborative way. We have some guidance, which is also sometimes important. So even if within a family. And therefore, I think like Shift Array, we started it, and I was in the process from the very beginning, and I really like this stream which we have now. So getting closer and closer and closer, and if we continue like this, I do not fear the future.
Yeah, and interesting that you say also failure, because sometimes research is really about also coming to sometimes to a conclusion that this is not a solution for rail, but that is not a failure itself. It's a good information for a decision on how to move forward. So it's really provide us with a good view of which way we should move on in practice.
Yeah.
Yeah, makes sense. I would also maybe add one element. All the innovations that have been presented today have been really been built up considering obviously the brownfield situation where we are, but also been built up with the idea that at the end we're creating one system. We're not creating plenty of different systems. And I think there is a novelty in what Europe's Rail have been doing, for example, compared to the past initiative of Shift to Rail. It's really linking more towards standardized type of activities and also linking much more to the rules and regulation of the European Union. And it is an advantage because it is a loop cycle. You research influence standard and standards influence research. And we needed to work in this way if we really want to achieve, one single type of European railway. And there is another element. All those innovations appear at the first glance costly because you needed to replace the system, you needed to upgrade them, etc., etc. But what we are considering is obviously the life cycle value. And the life cycle value become even more interesting, not only because those solutions will produce value by themselves, but also because those solutions will be European, meaning that on the long term, also the maintenance of the systems hopefully will be cheaper because it's a standardized type of system and it's not a bespoke one. And also resilience, it's another matter that I think fit well the equation, because in the moment where you have a safe and secure system that is proven at European scale, and I think also Roberto mentioned if it works in Sweden, so it works everywhere or something like this. So we should really have this approach that all our systems are for Europe and constitute at the end a resilience for the entire network.
And I think just in this direction, you might remember at the cross-border event, I was asked why it is so. What is the difference of having everything developed in the countries themselves or using products? What is the key benefit and what is the difference between both approaches? And what Giorgio just said. So the better we manage to share the costs, to prevent costs by, let's say, having a very clear structure, a modular approach with products which are highly, let's say, integrated, the easier we will have it to have affordable costs. So if every country, every customer in brackets from us suppliers is developing own tools which are very specialized, again, on the specific national solution, then it looks nice at the first view, but at the end it's very costly because they cannot benefit from the joint developments, from the joint lessons learned. So this cost-sharing exercise is a very important one because...
Yeah, and not only when investing in the system itself, but also for the maintenance. We can also share that burden because when we need to upgrade, update, and so on. So do you think it's maybe time for lunch?
It looks like. I hope all of you are hungry. So we have planned, I think, an hour lunch break.
Yeah.
So we will meet back at 1:15.
1:15 it is.
Yeah, we are looking forward to you.
You were there like a blowtorch burning. I was a key that could use a little turning. So tired that I couldn't even sleep. So many secrets I couldn't keep. Promised myself I wouldn't leave, but one more promise I couldn't keep. It seems no one can help me now. I'm in too deep, there's no way out. This time I have really let myself astray. Runaway train, never going back. Long way on a one-way track. Seems like
All aboard! We are now starting our journey towards the final event for Flagship Project 1, Motional. Please sit down and fasten your seatbelts.
Welcome back, and hope you had a wonderful lunch. We did here in Stockholm. Today we have more than 300 participants from 24 countries. Isn't that amazing? And now we will kick off the afternoon with the seamless mobility session. So, during this morning, we looked into how a railway system itself can become smarter from planning to operations. And this afternoon, we move forward and we look into the passenger's perspective on how rail can become easier to use and more easy to understand for someone who would like to travel cross-border. But also, what's behind the scenes, the digital foundations, which is the transversal topics. So, we will begin in Madrid. Okay, so Madrid have some connection issues. So this is, like running a train across Europe and something happens, and then we need to have some disruption management. And then we need those smart AI tools for having different scenarios to know how to manage this situation that occur. And luckily, there are also some planning of capacity in the background, so we have a good schedule on how to move on. So we will see. Do we have our colleagues with us? Yeah, great. So over to Madrid. Can you hear us?
Estamos en directo. Dile que estamos. Estamos en directo. Okay. Thank you, Linda.
Yeah, so welcome Marco, Enrique, and Victoria. who will show us the opportunities for seamless and inclusive mobility.
Yes, so welcome Marco and Enrique and Victoria. Ahora sí. Sí. Estamos.
¿Quieres decirle tú algo?
No, dile, habla.
Okay, so good afternoon, everyone. Greetings from Madrid. And well, this morning we were focused on how we can achieve operational excellence.
Es que hay retardo, no sé por qué.
Getting strategic planning and algorithms to improve our operations and simulations. It's one of the tasks that is very time consuming for infrastructure managers and operators, and it's really what keeps our trains running and the business running. But today I'm here a bit for a different topic. That is what is our political and societal mandate that keep all this technology development running. That is to serve the citizen and make them our passenger, and to respond to the growing demand of having sustainable mobility. So if we can have operational excellence, but without having the passenger with us, this will mean very little. So we need to attract them and make our networks really accessible, not only connecting rail, but also connecting other transport modes to the rail networks. And how we achieve this? By building bridges, digital bridges, to share data about information about how the people use our services in rail and how they can move to the other modes, but also the physical bridges, because they need to transfer from rail to metro, from rail to buses, and we need to make our stations accessible to make these changes easily. So that the passenger doesn't have to suffer anxiety during their trip because they don't know the schedules of their transport, or they don't know how to buy a ticket, what ticket to buy, or what happens if there are some disruption. And these are all topics that we will speak on this session here in Madrid with myself, tackling B2B connections and how we integrate with other modes. Enrique Jimenez from Indra about how we get inclusive services in rail, and Victoria Gurin from Renfe about how we can use demand information and how we can improve our operation with that. And to start, I will play a small video that consolidates our concept and our solutions that I hope you enjoy. I will just play it.
Connected Europe relies on rail as its backbone. Today, disconnected railway services and poor links to other transport modes leave too many passengers behind. In the FP1 MOTIONAL project, we've tested real solutions to bridge the gap between trains and the rest of the journey. We are proud to share this major milestone toward a seamless, barrier-free European travel for every citizen. In this video, we'll show how digital and physical tools developed in the project can make traveling across Europe smoother and operations more efficient. This is Anna. She is traveling from Munich to Bologna. Anna is a person with reduced mobility, and traveling well means autonomy and zero barriers. It all begins before leaving home. Anna plans her trip using a clear and accessible application, bringing together multimodal routes, schedules, prices, and inclusive options across rail and other transport modes. While Anna chooses, the system prepares. This is Luca, Railway Manager. His role is to anticipate demand, coordinate and adjust operation to deliver a good journey experience for everyone. Moving independently is key. From the station entrance to the correct platform, Anna receives step-by-step guidance from the totem and through her app. She approaches the totem, scans the QR code on her profile, and the totem indicates where she needs to go. A robot assistant then approaches. She places her luggage on top and follows it to the platform. Intelligent systems, including robot-guided assistance, multilingual QR code navigation, and a high-precision option accessible for blind users, offer her frictionless, stress-free support throughout her journey. Also, Anna's app provides continuous indoor guidance throughout the station. When the user approaches the gate, the application connects to it and access is granted. Anna enters the station without showing any ticket. The smart platform lights guide her to the correct train stop and show the occupancy of the compartments. As the train arrives, a red light increases her awareness. Anna has a smoother transition between platform and train because the gap between them has been reduced with the installation of the gap filler. In the operations center, Luca reviews demand forecasts and the digital twin of the transportation system, showing the prediction of density on platforms and trains. He sees that many travelers, including Anna, are planning to travel from Munich to Bologna today. Luca adjusts train schedules and resources to ensure a comfortable experience for everyone. For Luca, the platform provides forecasted flow, capacity, and library of situations to support decision-making, enabling managers to respond quickly to dynamic conditions while standardizing performance regardless of their personal experience level. Using forecasted operational data, Luca supports network adjustments and shares the information with operators, travelers, and other transport modes in multimodal environment. The journey flows, even when unexpected changes occur. The app alerts Anna to a disruption. The operator assessed different mitigation options, including tram, train, bus, and taxi. In this scenario, Luca selected train as an alternative to manage the disruption. Anna could use the guiding software in the app on her phone to go to the other platform and continue her trip. The system finalizes the trip seamlessly in the background. The experience extends beyond the station, with integrated door-to-door options across modes for a truly connected trip. An inclusive journey designed for everyone, from the first to the last mile. One Europe, one journey, zero barriers.
Okay, we are back. Hope you liked the trip from Anna and the experience from Luca on this video. We will go now through different demonstrations where we demonstrated the solutions that were part of this video. And I will start myself with B2B services and how we integrate different modes of transport with rail. And of course, we tried to focus on pain points of these two personas. And first, Anna, well, I believe most of us today travel with a mobile application to support our journeys. But if you want to travel in Europe, I don't know, by example, from Germany to Spain, probably you need 2 or 3 different railway applications. And if you want to include the urban parts, for the first and last mile, you need even more because this information is not connected. And when you arrive at your destination, probably you don't know what is the operator that you need to download the application, or what is the best local application. So also some blind spots. And on the Luca side, Luca wants to expand the service coverage by having information from other operators, but without having the burden of ingest data and maintain this data throughout the year. And on the other side, if he wants to provide data to third parties, he also don't want to lose data sovereignty and control. And speaking about multimodality, one other topic is to keep visibility on how the revenues is spread across the different players, and do not have delayed settlements that prevent our cash flow to be quickly on our hands. And starting with the first demonstration that we did, this demo was done in Luxembourg. That is a small country in the middle of Europe with a lot of daily commuters crossing the border every day. So we tried to first connect rail with other modes that support the access to rail, like car sharing or park and ride services for private cars. But the focus was on having cross-platform connections. So how we can get information from the side countries and side regions, so that the commuters that are going back and forwards can have the best information possible. And here we connected with the Saarland region on Germany. It was a partnership with FP6, but also with a system in Madrid. And all this was possible using an OGP interface that allowed us to exchange this information. And well, as I said, we connected to a platform in Madrid. That was also another of our demonstrations, where we also connected different modes and connected to different platforms, also using OGP. But we went one step further here, having the OSDM standard used to provide also tickets via online sales on one of these applications, even if Madrid and Germany is not connected. It was possible to prove that it's easy to do that. Then we had another demonstration in Sweden/Germany. This was one demonstration that we have some solutions already in production today, because we used OSDM to have the distribution and sales of tickets in Sweden. So SJ is today able to sell multimodal tickets, not only for their services, but for other rail operators or buses in Sweden, by example. All of this is consolidated through this OSDM interface. But they also tested how to sell tickets from DB from Germany, allowing to make a rail travel directly from Sweden to Germany, just with one application and just with one booking. On the German side, this was also done. So DB is today selling on their digital channels SJ tickets, which make this demonstration really a success, because it proved the value and went to the market directly. And another demonstration that we had in Europe was in Poland on the municipality of Lodz. Here what we tested was to create a data lake where allowed all the local operators to provide data in this data lake and uniformize the data, so that we can put some additional services on top, like journey planning for the region or prediction of passenger flows between other services that support the operation. And well, the next demonstration then was a corridor between Paris and Amsterdam, testing a financial platform where we had a multimodal mobility integration. So that we could have the urban parts from Paris and Amsterdam, and also the train between both cities, and have a common clearing, apportionment, and settlement processes to take care of all the transactions that were recorded on a distributed ledger, so that all the information is transparent to everyone and that the cash flows can reach their owner very quick. And the last demonstration on this work package was done in Italy, in the region of Puglia. This one focused on distribution, on disruption management using Siri messages. Here, using this interface to provide information to the travelers about disruptions, but also between operators to exchange information on how they can find the best mitigation strategies to resolve a situation of disruption. And well, from B2B services, those were the demonstrations available, and now I will call my colleague Enrique to talk a bit about inclusive rail-based mobility.
Thank you, Marco. Hi everyone. Well, I'm Enrique Jimenez from Indra. Good afternoon to you all. I'm here today to present the results of Work Package 23, which are focusing in seamless and inclusive mobility. Our objective in Work Package 23 was to make rail travel truly accessible, effortless and barrier-free for all passengers, especially passengers with disabilities. Our visibility, our vision from the beginning was really, well, it was really clear, as you have already seen on the video. Passengers with disabilities often face a lot of difficulties on a daily basis when traveling. So the question that we asked ourselves was, how can we make these difficulties disappear or nearly disappear when traveling for all of our passengers? So the answer to this question was to mix digital, physical, and innovation into a single seamless experience. So as you have seen, Anna's pain points in this case, they on a daily basis, they face a lot of, well, very limited assistance inside stations, a really lack of clear indoor guidance, and they often face stressful and difficult situations in ticket validation processes. So, since the beginning of the project, now 4 years ago, we have done a lot of research, development, and have finally demonstrated our solutions in real operational scenarios. And I'm here today to present these results. So our first demonstration was done here in Madrid. And here, what we achieved in Work Package 23, we didn't achieve single solutions. What we achieved was an integrated journey. Below the same platform, below the same application, we combined several technologies such as frictionless validation, indoor guidance, account-based ticketing, and also journey planning, which Marco has just explained in the Madrid demonstration in Work Package 21. And here, the main result was to, as I said, not create isolated solutions, was to create a really end-to-end seamless journey that worked and was really impactful above all for PRMs and for passengers with reduced mobility, where every friction point matters. The next demonstration was done in Malaga. That here was, well, we developed several complementary solutions. We expanded on the digital and interaction side. We developed an accessible mobile software. We developed an interactive totem and even an autonomous guidance robot. Here, all of this was designed to provide a multi-channel accessibility adaptive to every user need. The key point here to understand is that accessibility shouldn't be a one-size-fits-all. It should be adaptive, it should be flexible for every user need. The next demonstrations that we had one in Asturias and one in Malaga. The GoBoss demonstration was done in Malaga, which it's basically we projected light on the floor, or light signals, indicating accessible carriage positions. And gap filler, basically, we achieved the reduce of the gap between the train and the platform. This is a really key important point to reduce uncertainty and to improve independence for users when traveling. Our next demonstration was done in Amsterdam, the hands-free and seamless traveling. With this type of technology, we are giving passengers the ability or the opportunity to be located at the same exact time that they enter the station, the opportunity to notify the station staff if some problem happens, and the most important aspect of this technology is to give the opportunity to passengers to come and pass through the gates without showing a device, without having physical interaction with the gates. This is a really major step towards our accessible mobility, our seamless mobility, because we are seamlessly letting passengers come and go through gates, above all in busy environments, and losing time, very valuable time for each of our passengers. And last but not least, we also focused on what is the platform environment itself. We developed a solution called the Illuminated Platform Edge, which was demonstrated in Berlin and Leipzig. And with this type of technology, we are giving the passengers a lot of knowledge of what is the train that we are going to see on the station. We are seeing the position of the train inside the station. We are seeing the capacity information that this train has before entering, and real-time alerts. So we are improving a lot passengers' experience in this case, because we are giving them a lot of information that it's very valuable for them. They are better informed of what is the train that is going to enter the station. They are better positioned within the platform, and obviously safer. So, just to sum up, the key point that I wanted to, or the key takeaway from Work Package 23 that I want you to get, is that we have demonstrated inclusive mobility is no longer a vision. It is already achievable, and we have demonstrated that in Work Package 23. The real challenge now is how to scale it. Moving from individual solutions to one single or interoperable ecosystem that works across Europe. So in the end, seamless mobility is not everything about technology. What we want is to really ensure that every passenger can travel with confidence, independence, and dignity. So thank you very much. This has been all the results for Work Package 23, and now I give the floor to my colleague Victoria.
Thank you, Enrique. Hi, everyone. Good morning. Today, I would like to briefly present the work carried out under the common objective of anticipating demand in order to improve resource utilization. Although the demonstrations were developed by different partners across Europe, they all address different parts of the same operational challenge. So at this point, we focus principally in Luca, which is a rail manager or rail operator who has to take decisions with a different type of information. And in Madrid, the focus was on integrated multimodal disruption data into a common transport data hub. It was going to improve the incident management and provide passengers with timely information. In case of Italy, the emphasis was on the disruption recovery, optimizing alternative transport resources, such as buses and taxis under different scenarios. In France, the digital twin combined demand forecasting with operational simulations, allowing operators to test different timetables and passenger flow scenarios before taking decisions. In Catalonia, Spain, some predictive models were used to detect abnormal situation early and support proactive operational responses. For Malaga, we had a demand prediction that was applied to multimodal station management, helping operators and management to allocate better resources, to create different scenarios in order to improve the management of the station, and also to plan different alternative transport mode possibilities in case there are need for that. And in case of Poland, in Lodz Kalinska, the objective was to build an integrated data ecosystem capable of combining demand forecasting and disruption management to support operational planning. In Luxembourg and in Italy, it was demonstrated how demand forecasting can also improve journey planning, occupancy information, timetable robustness, and network optimization. So while each demonstration addressed different operational needs, they all converge toward the same vision, using data to move from reactive railway operation to predictive and collaborative decision-making. From my perspective, one of the main lessons learned from FP1 is that the challenge is no longer developing isolated predictive models. The next step is integrating these capabilities into a real operation processes where different actors, systems, and transport operators need to work together. This naturally leads us toward the ambitions of the next program phases, where digital twins, demand forecasting, operational intelligence, and AI can progressively evolve into a decision support system that help operators take faster, better informed, and more coordinated decisions. Thank you very much. And now I will take advantage to talk about the event 2 that we had the luck to hold in Madrid in May. And here you can have the opportunity to understand better all the demonstration that we were talking about if you want to have more details. And here you have different links for all, and also the recording of the whole event. And I hope you enjoy it. So now we are at the moment of questions and answers, and I hope my colleagues can join me, and we will hear Linda.
Thank you, Victoria. And I hope that you can see me now also in the studio in Stockholm. Yeah, it can really be challenging sometimes to travel by rail across Europe. But it seems like you have identified the problems and you have presented here the solutions. So it will become much easier for the future. And you have described here so many different interesting solutions. And what would you say would be the critical alignment or agreement that would be needed between European transport operators today? And what would you say would be the critical alignment or agreement that would be needed between European transport operators today? And
What would you say would be the critical alignment or agreement that would be needed between European transport operators today?
Okay, so if we look to the landscape today in Europe, we still don't have an EU-wide solution that all the operators can get on board. This is maybe because we have still some fragmentation in standards. So, by example, we have different countries using NetX or OSTM. Now we have a rising standard for shared mobility, and well, there is a initiative at CEN level that you did that is trying to consolidate a bit more this. After having this better consolidation, I believe we will be able to exchange better data between all the operators. But I think we also can do a bit better by digitizing the collaboration that the stakeholders have, so that we don't need to sign papers just to exchange data and go through these legal processes that are sometimes difficult, but also to automate the access of data. And here we also have some initiatives like the national access points, where we need to still deposit data and keep the quality of the data, but we also have other initiatives, by example, UIC, that is trying to have their open multimodal toolkit that facilitates this exchange of information. And I guess with all these tools that are ongoing, we already proved that it's possible to exchange information. But if everyone uses the same language, if everyone uses the same processes, then this will be much easier.
So thank you, Marco, Enrique, Victoria, the team in Madrid. And I must say that you really took the presentation of visualizing the results in a new, tasteful way. So thank you so much. And time flies, so now we move on to the next technical session, which is the digital foundation. So now we will look beneath the surface of the digital foundations, which is the base for many of the different innovations that we have seen today to make them actually work and work in connection to each other and together. So here with me in the studio in Stockholm, I have Svenja and Isabel, who will now present the results of the digital foundations. So welcome to both of you, and the stage is yours.
Yeah, we will start by perhaps describing the pain of why is it so difficult to digitize the railway sector and the public transport sector. We still have labor-intensive legacy systems. It's been mentioned throughout the day. We have a fragmentation of data. It is assumed available, but it's not always the case. Quality, interoperability is sometimes lacking, particularly between stakeholders. And stakeholders may not have the same degree of IT maturity, and the benefits of digitalization may not even come from the stakeholder providing data, so it might benefit the whole sector without benefiting some particular company. And on top of this, we have regulatory challenges, of course also opportunities, but challenges coming from the railway sector and the fast evolving IT sector. So the transversal topic have been working on issues addressing the whole ERJU projects across the projects and carried out work for a relevant digital foundation, and that's what we are coming to talk about, bearing in mind the improvement of services for the travel of goods and people So let's get into a bit more details.
Yes. So how do we tackle these challenges? Imagine we like having building blocks. You know, there is this one Danish brand, for example, you could think about. And we have more or less the same. So we have building blocks for data. One is data models, one is digital twin environment, one is data sharing. And these building blocks, you can combine them and build new structures, but still keep the flexibility to change it afterwards, however you need it to be. And this is the idea of the digital foundation. So we go into different steps here. And for Motional, we focused on the individual building blocks to create them. In Wave 2, you heard quite a bit about Wave 2 already. We will then see how they can be composed to build new buildings. And afterwards in Wave 3, we will see how this new created ecosystem can be beneficial for industry and consumers in the best way. You will hear today about these building blocks we created in Motional, but if you would also like to read a little bit about it, we have the Catalogue of Solution from Europe's Rail. You can look it there up. We have something about the planning and validation tool, about the rail data space, the modular digital twin for rails, and the databases for use cases. We'll come back to this one later.
So now we suggest showing you a number of pre-recorded videos showing some of the building blocks you've been talking about. We thought starting with the case-oriented digital asset engineering on the ETCS planning and validation. Before going to a more general approach, how do we talk the same language, meaning the shared semantics? Also talking about exchanging data in a safe and decentralized manner through the rail data space, and in the end consuming the data in modularized digital twins for rail. With a couple of examples, we have the example of the point machine and braking and traction. And we have also asked ERA's views on the transversal topics and how the work can be used further on for regulatory purposes. So you could please start all the videos.
Yeah, hi everyone. This is Asim from Deutsche Bahn. I am the work package lead for digital asset engineering. Now we are in our DB Gasometer office, which is in Berlin. So I am happy to present the digital asset engineering work package to you and all the tasks which we have completed in this work package. A most important part of our work package is that we are planning the ETCS level 2 objects without signals through our planning tool and also validating that data with our validation tool. We use the shacking rules to validate the data, and then that data is available for downstream systems. And we have other tasks as well, which we have completed, for example, object detection and data analysis through LiDAR data. And we have also another task like identifying the Wallis errors through the co-simulation or digital twin environment. We have another task where we have an industrialized tool through which we have used a schematic design of that tool to import and export that data model, the ERA-extended CCS-TMS data model. So we have diverse set of tasks which we have completed in digital asset engineering. And mostly it will resolve the issues of cross-border data transfers or cross-border projects where data transfer is needed, and also where we have to do planning projects, and it would save a lot of cost. Thank you very much, and then have a great day. Bye.
Across Europe, rail is more than infrastructure. It is a network connecting cities, moving people, powering economies. However, differences in operational rules and signaling systems render cross-border rail transport difficult. To overcome this, the European Rail Traffic Management System, ERTMS, was developed, introducing a standardized and continuous communication between train and trackside. While technology is available, planning and rollout of ERTMS throughout Europe takes time. The FP1 MOTIONAL project has addressed this through further automation and digitalization in European Train Control System ETCS planning. We developed a toolchain that plans ETCS Level 2 objects without signals and also validates that planned data. The planning is done with the engineering rules developed by the EEIG ERTMS user group and the European Railway Agency Extended Ontology CCS-TMS data model that is developed by the system pillar in coordination with the European Railway Agency. The output generated by the planning tool is subsequently subjected to validation using the validation tool. These results are presented through a geomap and a detailed report to ensure clarity and transparency. The same output can be expanded to the planning of interlockings and other rail infrastructure elements. These two tools enable faster planning, thereby supporting the rollout of ETCS Level 2, while reducing both costs and implementation effort. Building the digital railways of tomorrow.
Every minute the European railway network generates an ocean of digital information, sensors information, signaling data, passenger information. Having mountains of data does not ensure understanding it. If a track sensor detects a physical defect, the maintenance database sees infrastructure equipment requiring repair. To the dispatch system, however, that same defect might mean a temporary speed restriction. The data exists, but the context gets lost between the systems. Modern railway digital exchange where a shared semantic meaning for data across domains, organization and use cases. The conceptual data model, or CDM, functions as a semantic bridge between domain concepts and standards. The conceptual data model does not aim to be a new God model. It is modular by design. Each module has a clear responsibility. No single module attempts to solve every railway problem. The model combines stable building blocks, which can be extended as new operational needs emerge. Where mature standards exist, they are reused rather than reinvented. In practice, collaboration on business modeling takes the form of a structured method. First, railway operations are described in plain technical language. Next, the concepts used to describe domain objects and processes are isolated, clarified, and related to one another. Ambiguity is then removed, like in that train example, which can denote an information object, a process, or a physical object. The conceptual data model and its modules cater to a wide variety of railway digitalization needs, offering a pathway to systems interoperability, European scale. To test the CDM against reality, we used the Alnabru Mount Corridor, a cross-border dataset linking Norway and Sweden, from Alnabru Freight Yard to Mount Freight Yard in Sweden. 964 kilometers of track and more than 33,000 infrastructure objects. Working with it exposed the real interoperability challenges, shared profiles, a need for flexible location modeling, explicit semantics, and robust validation. Digital enablers work together, combining the clear semantics, controlled data exposure, to feed digital twins.
Hello, everybody. My name is Andreas from DLR, and I had the honor to lead the digital twin work in Motional. Well, digital twins are a well-known concept. Many, if not all, flagship projects exploit it, and they address important use cases such as visual certification, automated train operation, predictive maintenance, and so on. However, there's one specific idea that might be missed out if the work is focused on applications only. Rather than treating digital twins as monolithic solutions prone for vendor or supplier lock-in, we consider them to be assemblies made up of interoperable, composable components. This way, you can exchange, e.g., the brake module if the brake supplier changes, or use the track module for both the vehicle and track monitoring, and so on. So it's our vision to organize these components as assets to be traded and exchanged via the federal data space, where data is available as well. We want to avoid that wheels are rented again and again. We want to organize the reuse of existing components, speed up innovation, and provide a business model that generates revenue. So this is the idea behind modularized digital twins for rail. Thank you.
In railway operations, every moment matters, especially at the switch. Quad machines are critical assets controlling train direction, where precision, reliability, and safety are essential. At Hitachi Rail, we bring these assets into the digital world, creating a dynamic digital twin. Let me present you the electro-hydraulic pond machine LA26H of Hitachi Rail, which we modeled it as a digital twin. The physics-based model replicates real behavior of the pond machine, capturing motion dynamics, forces, and response to commands in real time. This is the modular class-based architecture developed in OpenModelica. Here you see the switch in action. I can animate the moment here. Smoothly transitioning between the positions just as it would in real operations. With this digital twin, we can monitor performance, detect anomalies, and predict potential failures before they occur, enabling smarter maintenance, improved reliability, and safer railway systems. This is the future of intelligent rail infrastructure using digital twins.
Hello, my name is Blas Blanco from CAF, an emotional project. We have been working in the generation of digital twins for the braking and traction system of railway vehicles. One of the main challenges in railway engineering is how to test and certify complex systems efficiently. Traditionally, this relies heavily on physical testing, which is expensive, time-consuming, and difficult to repeat under identical conditions. Our approach is using digital twins to support virtual workflow, where simulations are used throughout the entire development process, not only in early design stages. Our broader goal is to bring more of the development and validation process into the digital domain. The result is faster development and better use of engineering resources. In this use case, the digital twin is built following a modular approach based on FMUs. For example, traction control is represented through multiple independent FMUs, one per control unit. This preserves the system architecture while allowing scalability and interoperability, which are key for integrating the components from different suppliers. In the framework of this project, validation of the digital twin has been performed against real operational data from in-service vehicles. The validation uses driver command and compares the resulting motor and brake efforts of the different train units. The results show the ability of the digital twin to reproduce the real behavior of such a coupled modular system. In summary, this approach combines modular digital twins with real data validation to support more efficient and reliable railway engineering processes. Thank you.
Hello, I work at the
European Union Agency for Railways in the Interoperable and Cost-Effective Railway Department. My name is Marina Aguado. I've worked at data strategy level, approaching the rail digital transformation with semantic interoperability as a key enabler and with data ontology as its central artifact. Today, this semantic artifact is part of the European railway policy. And how is the work on transversal topics in Motional connected to ERA? There is a clear pipeline. Contributions from Europe's Rail Joint Undertaking feed into ERA recommendations. These recommendations then support the development of the TSIs, which are the regulatory framework for the European railway system. In an increasingly digital railway, data flows between railway actors and machines play a more and more relevant role in this pipeline. Those data flows evolve into digital-ready instructions for interoperability, machine computable, reusable, and compliant with European data policy principles. For example, the Data Act, and in particular Article 33, highlights the importance of semantic interoperability. From the work in Motional, I see four main takeaways. First, the transversal semantic modeling activities and the extensions of the ERA ontology. Second, the ERA CCS TMS extension has demonstrated how use cases can be built without transferring data between partners, simply through federated queries when actors rely on a common core ontology. Third, shackle rules as a semantic web standard can express engineering rules, embed in the TSIs, and facilitate automatic compliance check. This is a first step towards law as code, including ETCS-related shackle rules. Those are a couple of examples I put in the slides. And for the reuse of ERA semantic artifacts, including the ERA ontology, its extensions, and the ERA KG Sparkle endpoint as key components of the rail data space and its use cases. Looking towards Wave 2, I see an extension of these four areas. More ontology extensions, more engineering rules expressed in shackle, more reuse of European interoperable components, full integration of the ERA KG in the rail data space, and new real-time and critical data exchange use cases. Thank you.
Okay, thank you. I hope you enjoyed our videos. This work would have not been possible without the help of experts, European railway and IT experts. Some of those you can see on this picture. They represent a broad background with different challenges from different countries, and we've been working together towards harmonized solutions. So a big thank to all of you. Forward, the main takeaway here is that the tools and solutions developed in the Digital Foundation for the railway and public transport help at least two things: working across silos and legacy systems, and reducing the digital competence gap in the sector. Now, obviously, we haven't tackled all the issues we could have, and that is why we have a second phase in Wave 2.
Yes, exactly. So in Wave 2, we have some of the topics we'll continue you just heard about. We will go more into depth. As I said before, it's then more about how to combine it than actually working on it. So we will have a look at the data models again, so which is about how do we make data interoperable, how do we harmonize data so it can work together. We have the rail data space who is looking at how to make data available and but keeping the sovereignty of it. Then we have the digital twin environment, which is creating the environment for digital twins individually created. And we will have a slightly new focus also on cybersecurity, because when we handle here data and creating a digital environment for the European rail, of course, it needs to be secure in the end. And because these topics are of nature transversal, that's why they're called transversal topics. The benefits are transversal also. So we have benefits here for the environment, the digital environment in the end, not only for the infrastructure manager and the railway operators, but also for the suppliers and finally for the end users. So, yeah, this were our presentations and we're looking forward for the question.
Yeah, I can see that it's not only relevant for the emotional partners, the developments in the digital foundation.
Yes, exactly. So during the phase of the project, we already cooperated with other projects of Europe's Rail. You also saw the video for from ERA, so we are in contact with them, so to make sure that it fits for first of all, the Europe's Rail program, but then afterwards for all of the rail sector.
Yeah, indeed. And is there anything that you would like the listeners to have in mind regarding the transversal topics that you now presented here?
I may add that in addition to what we have presented, it's just a glimpse of what we can do and a fraction of railway use cases. We know many more use cases exist in the railway sector and public transport sector. And in fact, we have created a dynamic open database for the whole JU across projects again. So we can have IT and railway experts meeting and defining together the right metrics and the right artifacts. And it also shows the sheer magnitude of the task ahead of what a transversal topic could be, would need support for when we have already more than 500 use cases. And we just explained a few today. But at least in a very pragmatic way, it's a tool that is meant to help reducing the digital competence gap that we face in the sector and hopefully pave the way towards a more digital railway sector.
Yes, indeed. And I must catch up with something that we talked about a little bit in the break, that the setup with the two of you here today is really smart. Could you describe this also for the audience? It's like a handover here.
Yes, so I started in the Motional project in the rather in the end of the project, being involved, but Isabel has been there for longer. For the wave 2, I will be more involved in the transversal topics, and Isabel will take on some more responsibilities even in the project itself.
Great. As a technical coordinator.
Yeah, so congratulations.
Thank you.
Yeah. So thank you, Svenja and Isabel, for this really interesting insights. And Svenja will see us soon again in the panel discussions, and looking forward to that. Throughout the day, we have seen many impressive demonstrations, different technologies, different pilots and demonstrations, and different countries. And in the end, they all point at a common and joint goal to make rail work better across Europe and more seamlessly. And I think this really illustrates that we are in a good way on the right track, so to say. So we will now have a 5 minutes break. And we will then bring together several, not only Svenja and myself, but also more participants from today's sessions for a panel discussion. So see you in 5 minutes. So today we have seen so many different technologies, but it's really not about the technologies itself. It's really building blocks of a smarter railway system in Europe. And now we have come to the time when we are about to reflect and have a nice conversation. So with me here in the studio, I have now Giorgio, Magnus, Lars and Svenja, well-known faces by now since this day. So let's start. We have learned quite a lot here today. And what needs to happen next for these innovations to become part of everyday railway operations and to improve the travels and also the freight transportations for the future across Europe? Who would like to start?
I think let me go first. What you have recognized is that we have been talking about a lot of pilots and we have demonstrated them up to tier level 6, partly 7. And so next step will be definitely not only to extend the scope, but to bring them to a higher tier level. So we have to see what is missing to really implement them, because only then we can really feel, so the customer. And this is the container about which I talked, and the passenger at the very beginning. These are the ones who have to feel the improvements. And so far we have done a very big step, but the next step will be implementation. And therefore we need higher tier levels, even more demonstrations in mirror and shadow scenario with the infrastructure managers, for example. So that will be the next step to go in live operation.
Yeah. And how do you see it, Magnus? Yeah. What would be the next step?
I really like this picture that was shown by Digital Foundation with Lego puzzle pieces. Because I think during 3.5 years we have been working with this research for these 5 different areas that we have presented today. And we should be proud of our 70 demonstrations. And now we are building these puzzles. And I think all the different parts are important. And I also think that we have a very good ground to further work on. And in some areas, we are quite close to implementation. And the wall between having a demo to implementation is quite low, I would say. So I see a lot of possibilities.
And Giorgio, how do you see it?
Well, I see it that it's important not to lose momentum, because a lot has been done and good results have been achieved, lessons learned have been gathered out of it. But it's important to go up until the next step, until the end step. As Lars said, at the end, we are doing all of these for the passenger, for the cargo user, etc. But the only way to have benefit is to implement it. The risk that we have is that research and innovation provide good results, but sometimes get forgotten, because then the next step of the implementation never happened. And so it's really a push that is needed from all the sector players. And but it's not only a push per se. I mean, what we need to implement is what brings benefit, because infrastructure manager will not implement an industrial solution if there is no added value. And so all of this needs to emerge. I think this is, for me, the next step. And then let's not forget that we need also to continue to innovate. We are in a highly competitive market. Well, we do it for the benefit of Europe, but the benefit of our children is also to ensure that the industry in Europe remains strong. So also let's continue to invest in innovation, but capitalize from it.
Yeah, indeed. And I think you illustrated that quite well, Magnus, in your session there. Of the operations, how you cooperate with RailNet Europe, how you even integrate this in handbooks and in practical rollout already when you are in the deployment and in research phase. So already there we have seen some benefits from the area that you are exploring.
Yes, that is correct. So for me, this is a snowball that is starting to roll, and then it's quite easy in some ways. So what we did in this with YCS when we started 2016, the node was a black box, and now we have it transparent. We have the different railway undertakings and so on active, and lots of progress. And an important part have also been this information with RailNet Europe and their work with handbook, and this with railway collaborative decision making. And they also starting up a demo in Luxembourg for Bettenburg. So these working with examples. But I also would like to come back because we have ERTMS ETCS implementation on our iron ore line in northern Sweden. And what we discovered when we had this implementation was that we got lots of problems with our TMS system. So what I see that what we are doing here is with doing this research, we are building up capabilities for demonstration and test environment. And these test environments, then the implementation will be much smoother. And we have lots of integration challenges for the future. So I think research is really the way forward, I would say. And also to de-risk future implementation.
Yeah, so it's not so to work in sequence. It's more working in parallel and iterative, so to say. So it's not like research, deployment, implementation, and you are handing over. It's more about doing it in iteration and along the process to speed up the development and implementation, and then also benefit from it and not have so many child diseases.
That's correct. In some way, you need also to be flexible.
Yeah, indeed. Yeah.
And I think that's also a part of research, and I think you were into that as well.
Yes. And I think, by the way, we should not underestimate the work that we are doing here. It's also a cultural shift by simply the fact of working together in a European environment, multicultural environment, and also having this type of discussion. You know, in the rail sector, it's quite game changing. But I think this is what, at the end, the work that we're doing is bringing up to more agile approaches. You know, with the integration of digitalization, especially. Yeah. I mean, it's also, we've been saying it across the entire conference, it's an enabler. And it's an enabler for a transformation that can accelerate, have a snowball effect, but in any case, it can become, well, we can make a transformation quicker, less risky, and but especially maybe more, let's say, future-proof than currently how the rail system is designed.
Yeah, indeed. Yeah, and then that brings me back to the data session because you know it's about the Danish Lego. It has its revival here, but in Danish Lego there are so many different pieces and colors and shapes and so on. And that is really what you visualized also in the area of data. And there are so many solutions, but how do we come to a situation where we not end up with a bunch of solutions, but the right solutions?
Yes. So it's called Digital Foundation, not by mistake or by chance, but because the digital market is so so fastly evolving, we have to make sure that we have a good basis that is fitting together. That's why we said, okay, we are looking at the Legos and we are looking in wave 2 into how this can fit together. If there were any blind spots we didn't anticipate by working on the different pieces, and to fill them, but then to have a good basis, we can react on new solutions to integrate this, whatever there is coming. I mean, a couple of years ago, we didn't thought that there will be chatbots that are basically this involved now. So this is also a part of the digital world. We can't always know what is coming next year or the year after or the year after. So therefore, we have to have a good basis that is good integrated, a good ecosystem. This is why we are calling it an ecosystem that then can react and can be adapted afterwards to whatever there is and whatever is beneficial for the railway sector.
Sounds smart. So, coming to the next question here, who are the key partners to make this happen? Which organizations, which corporations or models or setups is needed to make this real?
I think if we have a look from the really overall perspective, then it's everybody in the railway sector. So there are all the various associations of different kind which need to be involved, because all of them have evolved over the years. So RNE is for sure, from the infrastructure point of view, one of the key ones. But also UIC plays a role, and ERA is very important, getting more and more importance. So I think we should not forget any of them. So we should try, let's say, to use all the resources, all the knowledge, all the expertise to an utmost. And there was a lot of, not a lot of, but there was some friction in the past. So because everybody was fighting for his place in the game. And I think this, at least from my feeling, got better in the last year. Not years, but year. But there's still some room. So, in fact, as I said, we have to act as a family. And when we talked a lot today, I got a little bit the feeling that it sounds like, we have a lot of ideas, so fancy ideas, and we want to work on them. But what we should not forget, we are doing this not because we have fancy ideas, but because we have challenges, we have pain points, we have something what we have to improve. It could be on one side from the customer really perspective. So the missing flexibility, the missing reliability, and so on, but also the cost perspective. So we really have to think about how to manage the costs, and how do we protect also investments? And that's why this combination of having research, how to bring this in products which are then much more cost efficient to be, let's say, maintained and also operated for the various purposes. This is really what is important, to find the right balance between research and innovation and deployment. And deployment is something much more complicated, as we said, than doing research and innovation.
Yeah, indeed. So during those 4 years, Giorgio, have the corporations in the sector changed?
Well, I think a lot, but it doesn't take, unfortunately, only 4 years. So actually, I bring a little bit of history, because I can see already the change before Shift to Rail, the predecessor of Europe's Rail, in Europe's Rail, and I can try to picture what is coming next. So before Shift to Rail, we had good bilateral collaboration in small projects that bring some results. In Europe's Rail, the collaboration enhancement, I think, was mainly across, not only, but I'm generalizing, mainly across suppliers. So the suppliers started to learn, okay, where are we fitting and how we can collaborate, something that they never did really before. And then in Europe's Rail, we brought another player, by the way, in Shift to Rail, also supplier in combination with academia research center. This also not to forget, because without this we cannot advance any research. And then in Europe's Rail, there was a significant addition of infrastructure managers. So the infrastructure manager roles and operating companies grew more and more. And this allowed us to have a different type of stakeholder relation, client-supplier, I would say, but client-supplier with the idea that also the clients needs to agree on common standard, common requirements that will be harmonized at the end across Europe. And this is a big change, because before this was not the case. We still have challenges, so I think it's important to reflect for the future. And Lars, I think, is totally right. By the way, your previous question seems to me a question of a job interview. Well replied. No, I think the next challenge is really the deployment. So here we are going to have also the need of other stakeholders, maybe in the same family, but different department. Because we need to go more into a commercial type of mindset, deployment type of mindset. We have started to put the seeds in Europe's Rail, and we have created the deployment group that provide advices on mature solution. Not yet the output of FP1, but we are focusing for the moment in the output of FP2, FRFCS, FP5 on the DAC, but TMS and well, with also the work of RNE, etc. I think this is the next one that will come, and this is the type of involvement and loop that you have mentioned before that we need to create as next type of stakeholder. There is another stakeholder that I will mention that was not mentioned, which is the public entity, beside the infrastructure manager that are also public entities. But European Commission, very much important, because they are setting up at the end the mandate to ERA on what to do in terms of regulation. And I think a setting like Europe's Rail, if it is happening as a next step, will be even more fundamental, because the closer we're getting to the market, the closer we're getting into regulation, standardization type of issues that needs to be discussed between the sector player and the public entity, which regulates, which provide also the public good, because at the end of what we are doing, it's a public service. We're ensuring that we have a sustainable transport mobility for everyone.
Yeah, and they also provide us with some finance.
This is a plus.
Yeah, to give us a little push and ensure that we actually are taking the joint responsibility in Europe, which is really helpful. And now I understand there will be a new fund that we have in front of us, also for research.
Yeah, so the European Union is currently reflecting on what is called the next multi-annual financial framework. It's basically the next cycle, 7-year cycle of the funding of the European Union. There is a big discussion. The discussion is happening in the Council, so between member states. There will be two interesting envelopes from our perspective. One is the envelope of research and innovation, the so-called Framework Program 10. The name for the moment is proposed to be the same, Horizon Europe. And this will be helping to fund the research and innovation more or less how it is happening right now. But then there is another interesting instrument that the Commission proposed, which is the European Competitiveness Funds. And this is really the instrument that has been put forward to bridge the gap between research and deployment. And I think it would be wise to think on how the rail sector could better make use of it. Yeah, as a next step, possibly there will be a continuation of Europe's rail joint undertaking. I exhort everyone to respond to the current call for evidence that is published on the Have a Say of the European Commission website, where the Commission asks, what do you think are the next step, the issues to solve, what do you see as evidence that worked in terms of joint undertakings. Yeah. And so reply to this, the deadline is the 14th of July. The more rail supporter they reply, the more chances they are that the Commission may propose a continuation of our rail JU, and maybe what we are hoping, a more enhanced rail joint undertaking as well.
Yes, and I can promise you Trafikverket will reply to the call for evidence. And as you could hear also in the start of this, in this morning, also Roberto encouraged to continue the good work of Europe's rail, because it's really important that we are connecting, especially for us in Sweden, who are a little bit like the suburbans of Europe. We really need to be connected with the rest of Europe. So it's really important that the goods and people can flow seamlessly. So in your area, Magnus, what would be the next step? What do you see in front of you? What will happen now when you have shown so good results?
Yeah. For me, it's very much of building knowledge and the competence together. That's what I think is important. And I think we are in a good situation to proceed in this wave 2 and wave 3. And I also think we are coming closer and already are to this with the implementation questions. So. And about the cross-border part, I think this capacity regulation is important. And in some way, I think more infra manager needs to be active in that part. So I think that will be developed during wave 2, I would say. So that's some things. Yeah.
And what would be the next steps in the digital foundation?
Yes, as mentioned, we have the alignment of the digital foundation we had, so especially about the data models, the digital twin and the data space, but we also have now the cybersecurity aspect. Before, of course, we didn't ignore cybersecurity, but it was more scattered. So everybody was thinking a little bit about cybersecurity, and now we have it more centralized, saying, okay, this is an overall issue we have to look at. Yeah, and also, of course, as someone from a research institute, as I said, there will be most likely some blind spots you only then see if you start stacking it together. So there will still be quite a number of research topics happening. And for the digital, this is also quite normal because, as I said, it's a very, very speedy market and speedy developments there. So there is always something new you have to then look into how to integrate it and how to use it. So it can be beneficial for the railway sector.
Yes, indeed. Yeah, and Lars, quite impressive results you have achieved here as a coordinator of Flagship 1.
It was a team.
Yeah, but you are exactly. You should be. So, what would be? What do you see in front of you? What would be the next steps now?
Yeah, to be honest, there I've, let's say, 2 roles now. As you know, I'm handing over for Motional 2. I'm handing the coordinator role to Pernilla from Trafikverket, and I'm doing, let's say, a little step back, which would give me the room to be even more, again, involved from the more direct content perspective. And I think what is so important, and there, coming back to the competitiveness also, call is really to find the best way to have, let's say, that all the investments which are needed for the future, that they are secured, and how to bring all the innovation in the products, because at the end we have to find the right mixture to ensure that the products are there which are needed with the right innovations in for a reasonable price, and only like this we can bring the sector forward. And there are, as we learned, so many additional features which are needed also for the capacity regulation and so on, and to work together with the sector organizations like R&E on this will be really my focus. So I really want to push this forward, there's a lot to be done, but one important statement I would like to do. So when I mentioned I had a great team, or we have been a great team, even if we achieved a lot, there's a lot to be done, and this is not a contradiction, because the challenge which we have in the sector is just so huge that even if we had a brilliant project, there will be work for the next years. So therefore it's always being motivated to do more.
Yeah, that sounds fantastic. And I must say it's been really awesome to share this day together with you and learn so much. But you know, time flies, and I really enjoyed the conversation also here together with you. But now it's actually time to summarize for you, Lars, and you will then round up the day. So we are soon coming to an end.
But before we doing this, many thanks, Linda, for a perfect moderation.
Oh, thank you so much.
A great pleasure having you here. You did a perfect job.
Thank you so much.
Yeah.
Done.
Thank you.
Thank you, Linda.
Yeah, and see you in the future.
Final event. I hope you enjoyed the day. You learned a lot about the achievements of hundreds of experts which we have presented today, and also in the last dedicated dissemination sessions. I can just repeat that if you are more interested in more details, look on our website, look on what is uploaded there. And if you want to support us, just drop us mails and send us input. We want to act as a family, as a sector, and it was a pleasure today with the colleagues to present you our results, and I'm looking forward to the next phase, which is then led or coordinated by Trafikverkehr directly, and consequently I hand over now to Magnus as our host, and many thanks for hosting this event here.
Thank you, Lars. And from Trafikverket side, I would first like to thank all the participants in our project for all your hard work. And I think we are standing on a good ground for the next wave. And I also want to further say to all persons that are interested, as Lars said, please get involved with us. We are working as transparent and in dialogue, and we are doing the first wave, and we are now looking forward for the second and third wave. And we are also having the perspective with the community and this with RailNet Europe and so on. And for today, I also want to thank, of course, all persons involved in this, with the moderators and planning and the studios. And it was very nice also with the studios from different parts in Europe. So that's anything more we should thank you about, Lars?
No, I think nothing to repeat. We wish you a nice afternoon, and looking forward to see you then at the final event latest of Motional 2.
Take the last train to Pottsville and I'll meet you at the station. You can be here by 4:30 'cause I've made your reservation. Don't be slow. No, no, no. No, no, no. 'Cause I'm leaving in the morning and I must see you again. We'll have one more night together till the morning brings my train and I must go. No, no, no. No, no, no. And I don't know if I'm ever coming home. Take the last train to Pottsville. I'll be waiting at the station. We'll have time for coffee, for later kisses, and a bit of conversation. No, no, no. No, no, no.